so dark. I'm trying to get the light better. Is that a little bit better? Okay. So we're going to be talking about inequalities. And I don't know if you remember what an inequality is, but an inequality is when you have this is the symbol you're seeing on the screen right now. That I'm not sure if it's turning around for you or not, so I'm being silly. Anyway, it's one of these two symbols, the less than and the greater than. Not an equal sign, but a less than or a greater than. That's what makes something an inequality. So if I say something like more than, not more than, at least, at most, those kinds of things have to be inequalities. Okay? Like to ride, I'm trying to think of something. I can't think of anything good that you might have seen. Oh, here's an example. Some restaurants, they have a children's menu and they say that you can eat off the children's menu if your age is 12 or under, right? You can be at most 12 years old or something like that. Right? That's an inequality because you can be in a range of values for that age. So inequalities always have an answer, a range, and it's kind of like they could shade it on a number line or they can shade it on a graph. Okay, so that's what inequalities are. They give you those shaded zones for an answer. So let me go ahead and flip the camera to my paper and get you started at looking at some notes. All right, so let me see if I have this in focus well enough for you to see it. I'm going to try and get it to fill up the screen a little bit better. Got to adjust my camera a little bit because I haven't used it in a few months, so it's not in the right place. Okay, so you see this thing right here that my finger's pointing to. That's an inequality on a number line. You could represent this inequality as x is less than -1 because it's all of the numbers that are smaller, less in value than the value -1. And do you see how, I'm going to zoom in again. You see how this is an open circle that's not filled in. So that means we're not including that, right? That -1 is not part of the answers. Good. Okay. So if I were to write the inequality for that, I might write x is less than -1. Okay. Now, that's not really what that drawing is there for. That drawing is there to display what we are calling a critical value. So a critical value is that spot on the number line where you have that circle. Okay. So the critical value for this graph is -1. Let's read through the rest of this definition. The number you get when you have solved an inequality. It is the number where you will place an open or closed circle on the graph. When you look at the graph, the reason they call it the critical value is because on one side of it, the answers are true, and on the other side, they're false. All of the numbers over here do not make this statement true. You know, all of the numbers over here, like the number 5, if I put in a 5 for this x, 5 is not less than -1. So every number over here would make this inequality false. And every number over here where it's shaded would make this inequality true. So that's how they use the critical values. They are kind of like the border between the true and the false zone. All right. So I'll try and help you remember that word critical, that name critical value, but it's brand new for you. So we'll have to keep using it to remember it. Now, I think you probably remember solving inequalities before. The biggest difference between solving an equation and an inequality is that with an inequality, you have to be very careful about reversals. So reversals are when you take your inequality symbol and switch it, all right? Reasons you might do that would be if you had to multiply or divide by a negative number, or what if you wanted to reverse the order that it's written in? What if you wanted to turn it around so that you could read it with the variable first? So we'll go through some examples like that, okay? Now, this says, whenever you solve an inequality, it's a lot like solving equations, except instead of an equal sign, you will have one of these symbols. That's the obvious difference, is it looks different. It has a different symbol. Then this, yeah.
I remember.
And you remember about the flipping it whenever you have to divide by a negative, right? That's what this star is right here on my notes. Let me read through. It
Yeah.
says, whenever you multiply or divide by a negative, it reverses the meaning of the whole inequality, so you have to flip the inequality symbol. Solve just like an equation, but watch those negatives, graph it on a number line, and then pick a number on the number line and test to see where it's true or false, and shade wherever it was true. So let me highlight that. Shade where true, because wherever it's true is where all of your answers are. Okay. So basically on this number line over here, if they had solved a problem and this was the answer to the problem, then here's where everything is true, and here's where everything is false, and here's your critical value where it changes from true to false. Okay. All right. Down here it says reminders. Make sure that you test where it's true and false when you shade. I just said that a moment ago, but it's like reminding you again. Flip the symbol if you divide or multiply by negative, and you can reverse the order of an inequality if you reverse the symbol too. This third one here, this one happens sometimes in problems when the variable is on the wrong side. So I'll make sure I remind you about that one. Okay, here's our first example. 42 minus 6x is greater than 12. So what do you think I should eliminate first if I want to get the variable isolated? Nice job. Yeah, we're going to eliminate that 42. So I'm going to write, here, let me get a colored pen instead of this black one. Okay, I'm going to write minus 42 on both sides of this symbol, right? So that's going to make a 0. 42 minus 42 is 0, so that's gone. I'm going to carry down this negative sign with the 6x. Carry down my inequality symbol. And then I have to do the math of 12 minus 42. So I can really just subtract 42 minus 12 and keep the sign of the bigger number, right? So what's 42 minus 12? Well, 2 minus 2 is 0. What's 4 minus 1? 3. So 42 minus 12 is 30. Now, which number was greater? The 42 is greater, so the answer has to have that sign. So it's negative.
No, boy.
All right. So when I divide, I'm going to divide both sides by what? Good. So we're going to divide by negative 6. Here, I'm picking out a different color that you can read better. That other one was too light. Okay, that's better. So now we'll divide by negative 6 on both sides. What are you always supposed to do if you multiply or divide by negative? Good. So we're going to flip this symbol the other way. Okay. So what is negative 6 divided by negative 6? What is any number What? Yeah, 1. That's right. Oh my goodness, my crazy light just decided to die. Oh well, that's fine. You can still see. My lamp in my room just quit working. So that's a 1 here, right? So that's 1x on that side. And then I'm going to write this symbol, which is a less than symbol. Now I have to do this math. -30 divided by -6.
Why?
Good job. So if 1x is less than 5, then that really means x is less than 5, right? So now what do I do with my number line? Good. So I'm just going to put 5 in the middle. I'm not going to put all the numbers. I'm just going to put 5, and maybe I'll put like, oops, I didn't mean to put a negative there. Oops. I'll put a 4 and I'll put a 6 just to show where we're at on the number line. And then what kind of circle at the 5? Do I color it in or do I leave it open?
Oh,
Nope. It's going to be open. So the only time you color it in is when they give us an equal symbol underneath the inequality, because coloring it in includes that number. So you include that number. Exactly. So everything that's less than 5 is going to be shaded here, where the numbers are smaller than 5. Yep, on the left. And there's our answer, okay? Sure.
No, I know.
Yeah. I understand. I like doing the boxes. Okay, here's the second problem. Example 2. Solve and graph the solution to the inequality. -6x plus 5 is less than x minus 12. So what should I do first? What would you like me to eliminate?
No, fine.
Okay. So I'm going to do -5 minus 5. And then that leaves me with -6x. This is a 0. I can carry down my less than. I can carry down my x. And I have to do the math with -12 minus 5. Nope, because they both have negative signs. So if they're both negative, you add them and keep the sign.
Negative. Negative.
Good. Okay. So now I have to do something else, don't I? Because I don't have all the x's together yet. So which one should I eliminate?
Yeah.
No, if you eliminate the -17, it's going to come over here with the 6x, and it's going to make the problem look like it did in the beginning, where you have the 6x with a number. So if you eliminate the 6x, that would put this over here, and we would have a 0 here, and we would have everything on that side. So if we're not going to eliminate the 6x, we're not going to eliminate the 17, what are we going to eliminate? Yep. So if we eliminate x and we get rid of that term there, see if I cover that up and it's gone. Now we have the x's all on one side and we have the numbers all on the other side. Isn't that how you want it to look when you were done solving?
Yeah.
That's how you can figure out what to eliminate. You can just pretend it's not there, and what will it look like if it's gone? Okay. So if I cover that up, it's how I want it to be. So we're going to eliminate that x. I'm going to write minus x and minus x. Now, did I divide or did I do a different operation?
Mine.
I did subtract, right? That's subtracting x. So do you remember that if I do division or multiplication, those are the times when I have to switch the symbol?
Yeah.
So I'm not going to switch this symbol because that was not dividing or multiplying. Okay. So what is negative 6 minus x? Like this is a negative 6x. This is just a negative 1x. No. What's negative 6 minus 1?
Negative 7.
Good. Negative 7x is less than, this zeroes out, and I carry down negative 17. Now what?
No more.
Good. Am I dividing by a positive or negative number?
Negative.
So then what do I have to do?
We'll go back.
Good job. So now I'm going to have 1x is greater than, and when you have a negative divided by a negative, the negative signs cancel each other out because a negative divided by a negative is a positive. So the final answer is going to be x is greater than 17 sevenths. That's your answer.
Yeah.
We have to put that on the number line.
Yeah.
So do you have any idea where that fraction is located between whole numbers? So here's what we would have to do. We would have to think, if I do 17 divided by 7, how many times will 7 divide into 17? What's 7 times 2?
Oh, me.
Good. And what's 7 times 3?
Oh. Oh.
Exactly. So isn't 17 in between 14 and 21?
Yeah.
So then it means that it's in between 2 and 3. This fraction is in between the whole number 2 and 3. Here's how I know that. 14 over 7 would equal 2. And 21 over 7, oops, I wrote the wrong thing. 21 over 7 would equal 3.
Yeah.
And you have 17 over 7. So that 17 over 7 is between these two things, right? It's between 14 sevenths and 21 sevenths. So it's between 2 and 3. So I'm going to put 2 and I'm going to put 3. Now, which one is 17 sevenths closer to? Is it closer to the 2 or the... Basically, I'm asking you, is 17 closer to 14 or 21?
Only one.
No. It's a little bit closer to 14. 14 plus what is 17?
Oh, me. Oh, me.
It's really picky of me, but it's going to be a little bit closer to the 2. It's going to be right here.
Oh.
Here's why. Because from the 2 to the 3, how many sevenths are there? There's 7 sevenths, right?
Yeah.
Like, you know, so it's got like 1 seventh, 2 seventh. This is 3 sevenths more right here because this is 14 sevenths. This is 17 sevenths, right? So it's kind of like 14 sevenths,
Okay,
and
I got you now.
16 and 17, 18, 19, 20, and then this is 21 sevenths right here. That makes sense, right?
Yeah.
Okay, good. So here's where your answer would be. Really, it's a critical value. Remember that definition? The critical value is that spot on the number line where we put the circle. So we have to put the circle at 17 sevenths. Now we have to
Hey,
decide.
no. What?
Is this a greater than or a less than?
Like,
It's greater.
what?
Yep, it's to the right. And there's your answer. Okay. Here's a little silly trick you can try to think of. This symbol and this symbol, which one of them looks more like an L if you were to tip it? This one looks more like an L. L for less. This one looks like a backwards L, doesn't it? So this one's greater. Okay.
Yeah.
Here's another way you could convince yourself. You can think of something that you know that's a fact about numbers that has a less than in it, like this. You know that the number 1 is less than 3. Okay? Did you know that the reason the symbol is shaped the way it's shaped is because it's kind of like you're taking the two lines that would be in the equal symbol and you're tipping them to show that one side is smaller than the other.
Yeah.
So when you make a symbol like this, you're saying this side is smaller and the number on the other side where it's opened up over here, this side of the symbol is the larger number. So that means I have to make the pointer of the symbol point at the smaller number.
Yeah.
So I know that's a less than symbol because I know 1 is less than 3. Okay?
I got you now.
All right. It's hard to remember it sometimes, but you can always look at it and figure it out. All right, let's do the third example. Solve and graph the solution to the inequality. What do you think I should do first with that one?
No.
You want me to do distributive?
Yeah.
Okay, I can do it that way. So if I distribute this, I would have negative 6x minus 6 is greater than negative 24. Add? What do you want me to add?
Yeah.
Okay. So I'll do plus 6 on both sides. All right. So now this is a 0.
Negative. Negative.
Good. Now what?
No, my. Negative.
Good comeback. Divide by negative 6.
Whatever.
Good. Okay, so now we have x is less than. Whenever we do negative divided by negative, the answer is going to be a positive number. Yep, 3. So on my number line, I can put a 3 and then put a 2 on this side and a 4 on that side. This is my critical value at 3. So that's where my circle goes. Do I need to color in my circle?
Yeah.
No.
No.
The only time you're going to color it in is if they have the equals bar, but none of these problems had an equals bar. Okay. So that's kind of a mistake on my part. I should have given you at least one that had the equal sign, but I forgot to. So you're not going to color that in. Now, this says X is less than 3. Where are the numbers that are smaller than 3? On the left or the right?
Oh,
Good. So we're going to shade this side. Now, do you remember me telling you earlier that you can test for true or false? We didn't even do that. So let's do it that way on this try. So we can pick a number over here where we shaded, and it's supposed to make the statement true. So let's choose the number 2. If I put a 2 where the X is 2 less than 3?
yeah.
Yes, it is. So we shaded it right. Over here where the 4 is, it better be false. So let's try that. Is 4 less than 3?
No.
No. So it's right. We've shaded it correctly.
Why?
Okay. So now it's time for us to look at a few practice problems, and we're not going to have time to do a lot because it's already 6:45-ish. I printed a practice page, so we're just going to look at a few of them.
I did good.
You what?
I did good.
You're being good? Is that what you said?
No, I did good. I did good.
You did good?
Yeah.
Yes, you did. You did great. On your math, you did really well. So we're going to try and do I think I just want to do a couple more of these problems that are in the middle here. And then when I talk to you next time, I want to do some more of these word problems, okay? And then on this page here, we'll do some of these. So these, I don't know if you see these right here. They say a word like and or inside of them. These are what you call a compound inequality. And that's what our next lesson will be about. It's basically like 2 rolled into 1 problem. So we'll get to those next time, but we need to do a couple of these here. All right. So yes, I'll zoom in. Okay. So this problem here, number 5, this looks a lot like our examples. Like, I'm going to be honest, I think it's almost too easy for you, but we could do that one. How about this one? This one looks like it's a little bit more of a challenge. I like number 6.
I want to do no
You want to do both. Of course you do. All right, so we'll do number 5 and number 6.
no more. No more.
Number 4?
No more.
I didn't understand what number you said.
No more.
7? Okay, can we just move on? We'll start with number 5. Now, I'm going to write it on another paper because there's no space to do the work on this page. So I'm just going to recopy it onto another paper. 3 times x plus 1 plus 2 is less than 11. Okay, got it. So let me see if I can get it on the camera now. Okay. Ooh, I got to zoom out. Too big. Let's see if we can get it to focus. It's all fuzzy. There. How's that?
Yeah.
Okay. So what would you like me to do first? Okay. So if I distribute, then I'm going to have
we
Okay.
no and violin.
That's a less than symbol. Remember the less thans look a lot like L? Okay. Because L is the first letter of less.
Yeah,
Yeah. Okay, now what do you want me to do?
my wait,
Hold on.
my combine
Yes.
I
Okay, so now what should I do?
my I
Okay.
with equals the
Well, less than, right? Less than 6.
I keep forgetting
That's okay. All right, now what do we do?
the my wait.
Okay. Now, should I flip the symbol if I divide by +3?
No,
No. Why?
because it's not negative.
Way to go. Yes, that is right. So X is less. Did you say 6 divided by 3 is 2? Is that what you're
Yeah,
saying? Yeah, that's right. So now I need what do I have to do next? Besides after I box it, what do I have to do?
on number one.
Good. So we'll put a number line. We'll put 2 in the middle. Then what?
Open
Open circle. Okay. Now, what other numbers can I put on this number line?
3.
Mm-hmm. And 1. Just go one above and one below. Okay.
And then go white.
Nope, you said it backwards. Because this is less than.
No, I keep forgetting.
Yeah, you're right. Your brain keeps having you do all of these less thans keep end up going backwards for you. But less than is always left, okay? It points to the left and it shades to the left. Less than is left because that's where the smaller numbers are on the number line. So if I pick any number over here like 0, 0 is less than 2. If I pick a number over here like 3, 3 is not less than 2. So it's false over here where the 3 is, and it's true over here where we shaded it. Okay, so that's number 5. Let's do number 6. Oh, they're using different variables. Okay, 5t minus 2 parentheses t plus 2 is greater than or equal to 8. We finally had one, an or equals to symbol. Yay. Okay. Let me get this right where you need to see it. Hold on. Okay, there it is. What would you like me to do first? Distribute?
Yeah.
Okay. Now, what number am I going to distribute? Nice job. Okay. So we're going to have 5t minus 2t. And if I distribute -2 times +2, what number is going to go here? Good. Okay. What should I do now?
And will make me wait.
Good. Right? Add what?
Oh,
Okay.
will me equal 12.
Greater than or equal to 12. Okay, now what?
Nobody but me.
Okay. T greater than or equal to 12 divided by 3 is? I just didn't understand what you said. Yeah, 4. Okay. All right. On my number line, that 4 is my critical value. So we're going to put 4 in the middle. We're going to go 1 below and 1 above the 4. So we're going to put a 3 and a 5. Do we want open circle or closed circle at 4?
Whoa.
Good. Closed because if it's equal, we have to include that number. So our critical value is 4. That means on one side of the 4, it's going to be shaded, and on the other side, it's going to be no shading. So let's just, instead of trying to say which way it's going to be shaded, let's pick a number and test. If we put 3 in for the T, is 3 greater than 4?
No.
No. So it's false over here probably. If I put in 5 for the T, is 5 greater than 4?
Yeah.
Yeah, so that's where I want to shade, where it's true. There we go. All right, we have one more, number 7. All right, here goes number 7. Last problem. So we have 2, and then they have a bracket and parentheses. 2y minus 1 plus y. Goodness, my phone's ringing. I'm going to answer it really quick, and I'll be right back to you. Hello? Hi, I'm finishing up my tutoring with Connor. Can I call you back in about 5 minutes? Okay, love you, bye. Okay, so after the y, we need to close the bracket, less than or equal to, oh, we have another with or equals, Connor. 5 parentheses y plus 3. Oh, it's a big problem. Are you ready? It's a big challenge.
Well, okay.
Say that again.
It'll be okay.
Yeah, everything's okay. My husband is out of town and he calls me every night when he's out of town just to make sure that I'm okay and just to talk to me about how my day was. So he was calling me, but I told him I will call him back in a few minutes. Okay. So when you have brackets and parentheses, it's like they're trying to break it up into extra groups, right? So you should look for the groups on the inside of the brackets first and see if you can simplify this. So almost like you're going to look at everything inside the brackets by itself first and ignore the rest of the problem, okay?
Yeah.
So is there something that you can do to combine like terms in that part?
No. Why?
Yeah, the y's. Okay. So we would have 2y plus y. So that would be,
We want.
yeah, and we would have 3y minus 1. And then it would be like this. We wouldn't need the parentheses anymore. So now we have this, okay? So now don't brackets work just like parentheses, really? So you're going to have to distribute, okay?
What? My name.
Good. Less than or equal. Now what do I put here? Plus 15. That's really good. Okay, now what do I want to do? Okay. Good job. Okay, now what? Minus which one? Nice work. Good job. Okay, so 6 minus 5 is going to leave us with how many y's? Good, 1 y. And then that's less than or equal to? Good. Now this doesn't really matter. We don't need to write the 1, so we can just write y is less than or equal to 17. All right, it's time for a number line. Oh, sorry. Yes, I'll box it in. Okay, so we need a number line. 17. We need to go 1 below 17 and 1 above 17. Okay, so 17 is my critical value. And good. Color it in. Yep. All right, so let me test the number 16. Is 16 less than 17?
Yeah.
Yep. So it should be shaded over here. Let's double check that. Is 18 less than 17?
No.
Nope. So it's true here and it's false there, and that's all good, right? We did it right. Great job today, Connor. All right, so I'm going to go ahead and press stop on your video, and then we'll talk about when we're going to meet again, okay? Here, I'll put it where you can see that whole problem. That was a big problem. Look at that. That was a huge problem. And if you want to see all of the ones you did, ooh, I don't even know if I can get it on the screen. Let me see. No, I can't even zoom out far enough. Let me pull the camera up. Ooh, that's a lot of work. That's everything you did just now. Those 3 really big problems. Plus you also did all of these notes. Oh my goodness, you just did so much work. Nice job today. Okay. So I'm going to press stop on your recording. Okay. Okay. So what we're doing with this first problem is we're just reviewing what we did together last week, which is called solving inequalities. And what we would do with this problem, I bet you know the answer. What should I do first, Connor? Say that again. Distributive property. Yeah,
Yeah.
I got you. Okay, so
Yeah.
3x, and then what? And then just recopy the rest, right? Okay, I got you. So from there, let me get a colored marker real quick going. Okay, so what do I want to do now? Nice. Okay, so we're going to do 3x plus 5 is less than 11. Okay, minus 5 on both. Nice. Okay. Now, can you remind me, when is it that we have to switch inequality symbols the other way? Because we didn't have to do it this time, but when do we have to do that? Yes, if you had divided by a negative in this problem, right? Yes. So since we didn't divide by a negative, we didn't have to reverse the symbol. Now we would put this on a number line. So 0, 1, 2. Do I want open or closed circle? Is that a tough word for you? Nope. Closed. Oh, no, you're right. I'm sorry. Open. You're right. I wasn't paying attention. I'm sorry. Okay. And then less than, is that going to make me shade left or right? Good. And that's what we worked on together last week. Okay. So now we're going to start with graphing inequalities, not just on the number line, but on the X and Y axis when you have both X and Y in your inequality equation. Okay. So I'm going to put the camera on the book, and let me see if I can put it where you can read the problems. It's a little bit. Is it blurry?
Yeah.
Oh, okay. Well, I will just write them down on a piece of paper then, okay? Because I don't know what is causing it to be blurry. I'm doing it like I usually do, and I haven't changed anything, so I don't know what the deal is. I can press the focus button and see if it helps.
No.
It's what?
Why you go for? Why you in that?
Oh, okay. Well, hold on just a second anyway, because I have to get up and go grab a piece of graph paper off of the printer, okay? So it's okay if you can't read it too well, because I'm going to rewrite them on another piece of paper. I just wanted you to see the problems that we're going to work with are these problems right here, okay? These problems. And when we graph them, they're going to look like this. Do you remember doing this a long time ago in Algebra 1 with me?
Yeah.
Okay. So what we have to do, I'll tell you what the steps are. What we will be doing is we will be putting this line on the graph first, and we will have to decide if it should be dotted or solid. And then we'll have to shade on one side or the other, depending on where it is true. Okay, so I'll be right back after I go grab the graph paper. But I'm going to leave the book open just so you can kind of look at that for a moment, okay? Hopefully it stays open. It's not behaving. Okay, there we go. I'll be right back. Okay, I got my graph paper. So I don't want to do every problem. I want to do some of each kind though. So I don't know if you can see very well because it's so tiny and it's the light is too bright, right? Let me see if I turn it a little bit dim if it helps. Not too much, but anyway. I don't know if you can read it. The ones at the top, they have just X or just Y. And the ones down here have X and Y. Can you sort of see that? How these look shorter and these look like longer inequalities?
Yeah.
So, yeah. So these up here, they have just one variable in them, just X or just Y. And what that will cause to happen is you'll have either a horizontal or a vertical line. Because if you have just Y, it's a vertical line. I mean, a horizontal, I meant. This is a just Y, right? This is Y less than or equal to 2. So this is a line through 2 on the Y-axis. They made it solid because it's less than or equals. And they shaded below because that's where the values are smaller. They're less below. Let me put the lights back. There. Okay, so let's go ahead and jump right in. I'll write the equations on a separate sheet of paper since it's so hard to read it off of this book, okay? So the first one I want to do with you is Y is greater than or equal to 5. So I'm going to write it down and let you look at it. That's what it looks like. So since it's just Y in the inequality, then it has to be horizontal. So I go straight to the Y-axis. So let me put some axes on here. I've got my old ruler back. Do you remember this ruler from when I was a little kid? Here's my little ruler, my little wooden ruler. Okay. Okay, so there's my X and Y axis. So if I'm dealing with Y greater than or equal to 5, then I need to go to 5 on my Y axis. Here's 1, 2, 3, 4, 5. And I'm going to put a mark there. And that horizontal line should go through that. Now, if it's greater than or equal to, do you want me to do a dotted or a solid line?
No.
Yes, that's right, solid. And then if I'm going to show where it's greater than, see that symbol is a greater than. If I'm going to show where it's greater than, then I need to shade where the numbers go higher than 5. So higher than 5 is above. And that's our graph for Y is greater than or equal to 5. Okay. All right, let's do the second one. Number 2. X is less than or equal to -3. X is less than or equal to -3. I'm going to zoom out just a little bit. There you go. So for X is less than or equal to -3, I need to put my X and Y axes on my graph. So let me start with that. Okay. Then where is -3? If I start in the middle, where do I need to go to get to x negative 3?
Now.
The x, not the y.
Wow.
Good. So here's my negative 3. And do I want dotted or solid?
No.
Good. Okay, now where are the x's less? Because they're saying less. So where do the x's get smaller? Do I need to shade this way to the left or to the right to get the smaller numbers?
Wow.
Good. And that's it, okay? That's how you do horizontal and vertical. So if you have strictly y and no x's in there, y's are always horizontal. If you have only x, then it's going to be vertical. All right, so now those are pretty basic, right? Those are easy to remember if you know your lines. So let's talk about what do we do if we have both x and y in the equation, or the inequality rather. So I'm going to write some new ones down on this paper. The next one I want to do is y is greater than negative 2x minus 4. And to do a good job with this, you have to remember about mx plus b. So do you remember what number is the m? Yeah, the negative 2, that's your m. So whenever you have a whole number, what do you have to do to turn it into a fraction for rise and run?
Oh, 1.
Good. So my rise will be negative 2 and my run will be 1. Okay. And now this number here, this is my b. So that's my y-intercept. So when I go to my graph, I put that y-intercept first, and then I do my rise and my run. So let's put a graph on here. Okay, so first thing is my y-intercept at negative 4. So if I start at the origin, where do I go to get to a y-intercept of negative 4?
Wow.
It's a
No.
y. Yeah. Where?
Down.
Good. So down 4 puts me right here. Now that is an actual point on my line, right? Your y-intercept is the place where your line crosses the y-axis, so you know this is part of your line. Now what do you do?
You got the fall. You fall.
Good. You plot your slope. So you start at that negative 4, and this is a rise negative 2 and a run 1. So down 2 over 1. And then I want to do it one more time to get a good line. Down 2 over 1.
Yeah. Okay.
Say that again.
Now you can do it up.
Oh, yes, I could go. Yeah, I could fill out the whole graph this way. You're right, I can. Okay, now what kind of line do I need?
No.
Dotted. Yes, I need dotted. So I'm going to put my ruler there, and I'm just going to make a bunch of dashes through all of these. Okay. And then my arrows. Now what do I do? We have our line, but we have to figure out where to shade it, right? Because our goal is to make it look kind of like this one here, right? Where this is like where the answers are. The shading is all the true answers. And where we don't have shading, that's where it will be false. I'm giving you a little hint. Why am I saying true and false?
Because the fall gonna be with the fly. And the fall gonna be with the fly.
Yep. So what numbers can I put in there? If I want to try a point, what do you think is the easiest number to plug into the inequality?
0.
Yes. So I'm going to put in 0 here and 0 there for both the x and the y because that's the coordinates at the origin, 0, 0. So 0 is greater than negative 2 times 0 minus 4. This stays 0. This is 0 because anything times 0 is 0. And then I carry down negative 4. So now I just write 0 is greater than negative 4.
Yeah.
Is that true or is that false?
Oh.
Well, is 0 greater than a negative number?
Yeah.
Yes. 0 is greater than all of the negative numbers, right? So this is true.
Yeah.
So since that is true, then that means that I should shade the graph at 0, 0. Okay. So I'm going to go to my graph and look where 0, 0 is. And that side, well, that point right there is part of the solution right there. That is a yes, that is true, which means that everything on that side is true. Okay. You ready to do another one?
Yeah.
Good. Okay. Negative 4x plus y is less than negative 7. Okay. This one is a little bit different because the one we did a moment ago, the y was already isolated. But now on this one, y is not by itself yet. So what would you like me to do?
My why?
Subtract y?
Yeah.
If I do that, won't it put the y over here with the 7?
Yeah.
Well, I really want to have y here by itself and get everything else over there. So I can have mx plus b on the other side.
Oh.
Okay, good. Thank you.
Yeah.
Yep, that's a 0. So I carry this down. I bring down my less than. Now, if I want it to be mx plus b, then I should write the x term first. So I'm going to carry down the 4x next. And then here's my b, negative 7. Okay?
Yeah.
All right. So then what is my y-intercept?
What?
No, that's my slope. My
Yeah.
slope. Yeah, negative
No.
7 is my y-intercept.
I meant no.
Yeah, okay. Sometimes that happens, right? Sometimes you just say the opposite of what you mean to say. Okay, so this is your y-intercept. This is your slope. What do I have to do about my slope?
Why?
Good. Okay, so let me go to my graph now. So we had a y-intercept of -7 and a slope of 4/1. Okay. So -7 is my y-intercept. So do I want to go left or do I want to go down?
What? No.
Good. 1, 2, 3, 4, 5, 6, 7. Have you had a long day? Are you really tired? Is that what's going on?
No. No. Because I didn't do my I will.
That's Well, it's been a week, but you're going to get back into it, right? You're going to get used to it again. It's okay. So do you remember that your slope is 4/1? So we're going to go to this -7 and we're going to go up 4 and over 1, right? Okay. And then do it again, up 4/1 until we go off the graph. There we go. What kind of line should I have for this inequality with this symbol? Do I want dotted or solid?
Die.
Good. Okay, what do I do now?
Hey.
Yeah, we have to shade it. You're right. So we're going to test what point? Is the letter Z hard for you to say?
Yeah.
Yeah, okay, that's fine. It's at 0. So let's put the zeros in. 0 is less than 4 times 0 minus 7.
I call it a O. We call it what a O, but it's zero.
It's because you what?
And I call it a O, but it's zero. And I call it a O.
Oh, an O instead of 0. Sure, sure. So now what should I write on the next line?
Oh.
Yep.
No, 9.
We should just be carrying this number down here. So -7. Okay? Because the 4 times 0, this 4 times 0 is just nothing. Because anything times 0 is just 0. So we're carrying down this, and we're carrying down the less than, and we're carrying down the -7.
Yeah.
Is 0 less than a negative number?
No.
Nope. So this is false. So that means it's false for 0, 0. So I'm going to the graph, and I'm going to look where 0, 0 is. That is not part of the solution. I cannot color it because it's false there.
Yeah.
So I have to color and shade in the other side. Okay?
I got it now.
Awesome. So let's do just one more, and then that's enough of these. So number 5.
And then no.
Then what?
And then no.
My notes?
Oh, in my no.
I don't think we have notes tonight. No. So I'm just looking for one more problem that's a good problem. Give me one moment. This is a good one. 5x minus 2y is less than or equal to 6. This is a really good one. So what if we have a problem like this and we have to get y by itself? What should we eliminate? Good. Now, when I go to carry down, I have to be careful. So what should I say when I carry down this term?
Negative.
Good. And then we want less than or equals to. When I go to write the part on this side, I want to be mx plus b. So what should I put first?
Negative.
Good job, Connor. I know what you mean, buddy. I don't want you to talk too much because I can tell you're tired with the talking. So it's okay. I'm going to just try and get little words from you so you don't wear yourself out. So on this line,
I begin at 8 o'clock.
oh, wow. Yeah. I wish I could get up at 8 o'clock. That would be awesome. You know what time I get up? 5 o'clock. Okay, so if I want y by itself, what do I have to do? I'm going to divide off the -2, okay?
That's why.
And if I do it there, then don't I have to do it to this whole side here?
Yeah.
So the easy way to do that for these equations is to make everything be a fraction of that number.
Yeah.
Okay. Okay. Then this is just a 1 because anything divided by itself is 1. So this becomes just y. Then I bring down my, oops, I messed up. I have to flip my symbol, don't I? Because I divided by a negative number.
Yeah.
So I have to flip that the other way. Now, if I have a negative divided by a negative, doesn't that make the number positive? So this will be 5/2 x. And then what is 6 divided by -2?
Negative.
Good work. So this is what we're going to put on the graph. Y is greater than 5/2 x minus 3. So we decided to do this because it's easier to graph this kind of line. All right. So let me put my x and y axis on there. What's wrong?
Is there any way we can be more that way I can get
Yeah.
caught?
Yeah, let's talk about that after we finish this problem, okay? Because I'm gonna hit stop on the recording and we can talk about when to meet, okay? So we're gonna put -3. That's our y-intercept. So that's going on the y-axis at -3. Then we have our slope. Our slope is 5/2. So we're going to start at that -3y intercept and go rise 5, run 2. So 1, 2, 3, 4, 5 over 2. And then I'm going to do it again. Up 5 and over 2. And then one time backwards. Down 5, backwards 2. Okay. Do I want a dotted or a solid line for this symbol here? See how that's got a line under it?
No.
Good. Oops, are you okay over there? You didn't fall out of your chair, did you? Am I funny? Okay, you didn't break anything, did you? Okay, so this, now what do? We've got the line on the graph. Now we're going to do what?
Name.
We're going to test it for shading. You're right. So let's go. 0 is greater than or equal to 5/2 times 0 minus 3. But if you go times 0, then that's nothing because that's a 0. So 0 is greater than or equal to -3. Okay, let me put my paper where you can read it. So you can read that, right? Is 0 greater than a negative number?
Yeah.
Yes.
Yeah. We always go with it.
Yep, it's always greater than a negative. So here we go. We're going to shade where the side where the 0 is. So that's it right there. Okay. So that was the last one. Now, let me go ahead and stop the recording and we can talk about next time. Okay. Ooh, I need to write something down really quick. I learned that the bottom of the screen has the code for the video that helps me search for it. But I have to write the code down before I press stop. Okay. Okay, so these notes are for a review lesson that we did last Friday, and it's about solving absolute value equations. And it's also not just that, but it's also solving compound inequalities. So it's both of those things. Compound inequalities and absolute value equations. So if you end up wanting to review it even more after this video, you could maybe look for another video on that topic, okay? So absolute value cannot be negative. Do you remember that absolute value of a number is always positive? What did you say?
I remember.
Oh, good. So what goes here is whenever you have a negative number on the outside of the absolute value, then there's no solution. I should show you what I mean by that, but I'll show you in a minute. And then when absolute value is equal to 0, the expression equals 0, and there's only one solution. I'm abbreviating solution, SOLN. And when absolute value is positive, the expression has two solutions. One of them comes from doing the equation just like it's written without the bars, and the other one comes from making it negative. And I need to show you how to do that, okay? So we're going to work these 3 problems together to remember how that goes. So this first one says 5x plus 15, plus 12, and it's the absolute value of that, right? So what you have to do is when it's equal to 0, there's exactly one solution because 0 can't be positive and negative.
Mark it down.
Yep. So 5x plus 12 equals 0 and work it out.
-12.
Good. 5x equals -12.
Nearby.
X equals, and this will be -2.4 if we use a calculator.
Yeah.
So it only has one solution because it was equal to 0. Now let's look at this one. We have to isolate the absolute value expression first. So the first thing we have to do is get rid of this 7. Now 12 is a positive number, right? So this is that thing I was talking about earlier. You have to work two separate problems.
Yeah.
One that we just do with everything the same and you just drop the bars. This is called the positive case because everything is staying positive. And one
With
where
the negative case.
good job. All right, so now for all of these, we're going to add 4. So this is 2x equals 16. And on this one, it's 2x equals -8. Then we have, good. So we're going to divide.
-8.
And what's this one over here?
-4.
Nice work. So this one has two solutions because it had a positive number. All right, now let's look at this last one. Now see how this starts off having a negative number here, and we talked earlier about how you're not supposed to have solutions when it's a negative number. But the absolute value expression has not been isolated yet. It has that -2 in the denominator. And that means divided by -2, right? So I can eliminate that. I can go times -2 on both sides of that equation, and it will eliminate this denominator, right? So it will leave the 3x minus 1 equal to a positive 20 now. So I actually don't have a negative, do I? Good. So I'm going to go 20 equals 3x minus 1. And 20 equals, -20 equals 3x minus 1. And now what? Good. 21 equals 3x. And -19 equals 3x.
Never.
Good. Now this is 7 equals x, which is the same thing as x equals 7. And this one is negative. Well, that just has to stay -19/3 because it's a repeating decimal. It's 6.3 repeating. And so when it repeats, you just have to leave it as a fraction. So there's our two answers. Okay, so that is your reminder of how to do absolute value equations. You did an awesome, awesome job remembering how to do those. Okay, so up here, I just want to add a little tiny thing to the notes. It says when absolute value is positive, the expression has two solutions. I'm just going to add a note that says you have to work a positive case and a negative case. Because I feel like that was missing from the notes. You have to work a positive case and a negative case. Okay, so now this blank space here, this is space for us to make notes about the other half, which is the compound inequalities. We have to talk about compound inequalities. So this style of inequality here, where you have the shading is between 2 points, this style of inequality usually happens when you have your inequality written with less thans. Something sort of like, well, I can write this one with less thans. -4 is less than or equal to x is less than 2. That's the solution that they have written here. So they usually refer to this as being an and inequality because it's everything that's less than 2 and it's greater than -4. This one down at the bottom, this one is what you usually refer to as being an or inequality because the answer is either here or there. With the and inequalities, it's in both places between the 2 points, but with an or, it's here or it's there. And the way you write those is x is less than -1 or x is greater than 3. Okay? So the way you get these kinds of answers is that you have more than one inequality symbol in your problem. Okay? They're called compound. So either they will write the problem and you'll split it into 2 problems. Like, let me write one. -3 is less than -2x plus 1 is less than or equal to 9. You can split it into 2 separate problems and work this problem and then work this problem. Do you remember those?
Yeah.
Good. So they call it compound because it's really 2 inequalities in one. So split the problem and work 2 separate inequalities.
Yeah.
Okay, so let's do our examples for that, okay? So down here, I've got this first one, which really matches the same thing you were just looking at. So we're going to first do this problem. So I'm going to write that over to the side. -3 is less than -2x plus 1. And then second, we're going to do nice job. So we'll work both of those questions, okay? So if we want to isolate x, what will we have to do? Close, but not quite right. Yeah, we have to subtract 1 because it's already positive. Okay. So -3 minus 1, what does that give us?
-1.
Good. And then carry down -2x. What is 9 minus 1? 8. Now what? Okay. So -4 divided by -2, what is that? Good.
You won't that one.
Goodness, I messed up. Sorry. Okay, now what? -4. You got it. So now this is backwards, right? So to rewrite it in the forwards way, it should be less than 2. So we have
No.
x is less than 2.
No. Wait a minute. Wait a minute. Wait a minute.
Well, I
No.
flipped. So when I wrote the green one, it was because we divided by a negative.
Oh.
So I flipped my symbol because we divided by a negative.
Oh.
But then I rewrote it this way to put the x first.
Oh.
Okay. So now we have x is less than 2. And this one already has x first. So this is x is greater than or equal to -4. So when I go to put this on my number line, I need the critical values. That just means the special numbers on the graph. Those critical values are -4 and +2. And I need to circle those. Do I need to color those in? Look at your inequality symbols.
No.
Which one? There was one of them is different than the other. This is just less than. This one is greater than or equals to.
Yeah.
So which one do I color in?
Greater than.
Good. Now to be greater than -4, that means I'm going to color this way, right?
Yeah.
And to be less than 2 means I'm going to color that way. So it's basically the place where they overlap, you know? Because one of them has this solution and the other one has that solution, right? So where it's less than 2 is all of this.
Yeah.
And where it's greater than or equal to -4, it's all of that. But the place that is both pink and green is just right here in between. Okay? So that's why my answer is the part that I colored in black.
Yeah.
Okay. So you see how this is in between the 2 points. And the symbols in the original inequality were less than symbols, right?
Yeah.
So do you remember me talking with you earlier and telling you that when it's between the 2 points, it always has a less than and a less than?
Yeah.
And when it's the other style, when it's on the outer part, it's a greater than kind of problem in the original problem. So let's look. Let's look and see what happens. Oh, this one's not like that. So let me write you a new problem. This one we don't even need to do. This is not a good problem. Let's do another inequality problem. Let me write you one. So let's do let me find one that's written down here. Hold on just a second. I guess I have to make one up. Oh, I know where I can find one. Just a second. My screen is going to freeze for a moment, but I'll be right back, okay? It's just going to take me a moment longer because my computer's acting silly. Okay. All right. So I've got a problem. Let me write it down. I've got 2x plus 4 is greater than 6, or negative 2x plus 4 is, I think this works. Okay. All right, let me close that file. Okay, so this is the problem we're going to work. 2x plus 4 is greater than 6, or negative 2x plus 4 is greater than or equal to 6. Okay? So let's work this. If we work this one on the left,
Right.
4. Yep.
Oh,
And that gives us 2x is greater than 2.
right.
X is greater than 1, right? Then when we do this other one, minus 4, negative 2x is greater than or equal to positive 2, right?
Right.
We're dividing by negative, so we're going to flip our symbol the other way. X is less than or equal to negative 1. So this one has a different style of answer. When we shade this one on the number line, our critical values are positive 1 and negative 1. And then it's got just greater than for the positive 1. So that has to be an open circle that's ghosted out.
Go
But this,
right.
this would other at the negative 1. Oh, you said go right? Yeah, that was true. And then for the negative 1, go
left.
good. And just being really careful to pay attention that the symbol on this other one has a less than or equals. So I made sure I colored that one in. Okay. This is what you call an OR inequality. OR inequalities have 2 parts on the number line, 2 zones. Okay.
Yeah.
All right. So that's everything. Let me hit the stop button. It's okay. So this is what we covered in class on Tuesday. It's called absolute value inequalities. Okay, so basically it's mixing together the two things that we just talked about. Absolute value mixed together with inequalities. So let me put the camera on my paper and get going. Let's go. So here we go. You remember when we were talking just a moment ago about compound inequalities, we discussed the fact that if you have the inequality being graphed between the 2 points like this, then we call it an and inequality, and those always have less than symbols in them. And if it has the solution graphed on the outside edges like this, that's called an OR inequality, and it's greater than in the inequality.
Yeah,
Okay.
you told me that a while ago.
What'd you just say?
I remember that.
Good, good. All right, so we don't even need to do this review question here was for people who had not just talked about inequalities, but you and I just did that a moment ago. So I'm going to skip this. So we're just going to jump right in and understand what does absolute value with an inequality mean, okay? And I think it will help you if instead of doing this here in your notes, I'm going to do something to explain. If you were going to talk about the absolute value of x minus 2 is less than 4, then the expression x minus 2, you don't know what number x is, but you know that when you subtract 2 numbers, you find out how far apart they are. So how far apart x and 2 are is less than 4. So it could be 4, it could be 3, well, no, less than 4. So 3.5, 3, 2, 1, all the way down to 0, or even a negative number, except that you can't get a negative number with absolute value, okay? So basically, the number 2 is going to be in the center of this whole situation because you're taking that number you don't know minus 2. So how far that number you don't know is away from the 2 is less than 4 units. So if I go 1, 2, 3, 4, and 1, 2, 3, 4. So now I'm at 6 and I'm at negative 2. Anything between here, but not including this number. So anything in these zones will be less than 4 units away from the number 2, right? So x can be anywhere in here. And if x is any number inside of here, when you go x minus 2, the answer will be less than 4. And x can also be a number anywhere inside of here. And when you do x minus 2, you'll get less than 4.
Yeah.
Well, if it's a greater than, it's the same idea, except that instead of it being smaller than 4 units away from the 2,
It'll be more.
good. So if I've got 2 here, 1, 2, 3, 4, 1, 2, 3, 4, I still have the same critical values on my number line.
Ain't even more over.
Oh, sorry. There you go. So now it's going to shade this way, right?
What?
Because now I'm more than 4 units away from the 2. So this is a very complicated thing to think about, but I think you understand. All right. I'm going to pause right there for a second. I'll be right back. I got to go let Puppy back in. Be right back.
Come on, Gigi. Gigi. I was.
Okay, I'm back. So now we're going to do that with absolute value. So we'll work both of these problems together. So this first one here, what we want to do is we want to think back on what we were doing on that other sheet of notes where we had to split into 2 problems, the positive case and the negative case. And we're going to do that. So we're going to have 2 problems to work. And for the positive case, we're going to work 2x minus 1 is greater than 12. The only difference between what we did before and what we're doing now is that now instead of an equals here, it's an inequality symbol.
Yeah.
And then we have to do the negative case. So for the negative case, since it's an inequality, if we're going to change the 12 to a negative 12, we also have to flip the symbol because of our rules about inequalities.
Yeah, I always knew that.
Good. So now we're going to do what we would have done before. We're going to go plus 1. Yep. And we have 2x is greater than 13. And 2x is less than negative 11. Good. And now we have x is greater than 6.5. And x is less than negative 5.5. And we're going to put these on the number line. So our 2 critical values are negative 5.5 and positive 6.5. Do I want to color those points in or do I want to have them ghosted and open? Do I want this to be colored in or open?
I'm not. I'm sorry. I was getting
Oh, that's okay, Connor. So look at the inequality symbols. They just have a greater than, but not an or equals to.
open.
So open. Yep. So then,
Wow.
yeah. So do you remember what we said earlier about the symbols and the and or? When we have a greater than on the original problem, is that an and or an or? Do you remember? This is an or, which means it's going to shade out here on the outside part. And we can double check that with what these say. So greater than 6.5 is over here. Less than negative 5.5 is over here. So yep, it worked out right, didn't it? And another way you can check it is you can plug in 0 if you want. If we plug in 0, 0 is in this middle zone between the negative and the positive, right? So if I plug in 0, it should come out false because it's in the part that we're not shading. So if I go to the original inequality and I plug in a 0 for this x, I would have 2 times 0, which is 0. 0 minus 1 is negative 1. What's the absolute value of negative 1? Is 1 greater than 12? No, false. So it's false at 0. So since it's false at 0, we don't shade at 0. So we did it right. Okay?
Yeah.
All right. Now we're going to do one more together. And this problem is more complicated because the one we did earlier, it only has the absolute value expression isolated by itself.
Yeah.
And this one has operations that we have to do first. So the first step is to isolate that. So if I want to isolate all of this absolute value, I have to eliminate this plus 1. Okay? So we're going to do all of this before we even split it. We're not going to split it into two problems until we isolate this. Okay? And then once this is isolated, then we can split it into two parts. So minus 1, minus 1. Then I have 5 times the absolute value of 2x plus 3 is less than or equal to 33. Then I have to divide by the 5, right?
Yeah.
So divide by 5, divide by 5. Now I have the absolute value of 2x plus 3 is less than or equal to, and when you do 33 divided by 5, you get 6.6.
Putting it down.
Nice. So we're going to write 2x plus 3 less than or equal to, yeah, I wrote the right thing. And for the negative case, 2x plus 3 greater than or equal to negative 6.6. So I'm switching my symbol and changing my sign. All right. 2x is less than or equal to 3.6, and 2x is greater than or equal to negative 9.6. Now, good. Divide by 2. Now we have x is less than or equal to 1.8, and x is greater than or equal to negative 4.8. Okay, so those two solutions, when I put them on the number line, those are my critical values, and they're telling me which way to shade. So negative 4.8 and positive 1.8. Do I want open or closed circles?
Oh.
Good. And then less than the 1.8, excuse me, that would be this way, wouldn't it? It would be to the left, and greater than or equal to the negative 4.8 To the right. So where those two things overlap, shouldn't that be in the middle?
Yeah.
And let me look up here and see. We have a less than symbol. Oops, I should be looking right here. I was telling you the wrong thing. I should be looking at this when I'm trying to decide, because this is where it was already isolated. Okay. So when I'm looking at the isolated expression, that's a less than or equals. So this is an and inequality because of the less than or equals. And is always in the middle. So there I go, in the middle. So that basically it's false over here, it's true here, and it's false over there, right?
What?
Okay, so you feel like you understand really well?
Yeah.
Good. All right, so I'm going to press stop, and then maybe if I have time sometime, I don't know if I will have time, but if I get a chance, I'll maybe try and do a couple more problems later and post another video, okay?
And then what we do, wow.
What we did what?
When we do this.
When did we do this?
Yeah.
Oh, we learned this in Algebra 1. We probably learned it either like in the fall, like in November, or maybe in January. I don't remember exactly, but that's when you learned it. So it would have been, it would have been before the COVID break, but not right before it, maybe 2 months before it. So this is called systems of equations. Now I'm going to work this first problem together with you. This was their bell work problem today, okay? And it says to graph the following linear equations on the same graph together. So first one I'm going to do is, yeah, so what do I put on my graph first?
No, I know.
Nice job. So we'll put that at 1, and then we'll do a slope of -2 over. So that's going to be like this, right?
Yeah.
Okay, so that's that graph. And then we have to graph the other line. So the other one has a y-intercept. Good. And what's that slope? Good. So we're going to go from the -1, we're going to go up 3 over 2.
Yeah, I am
And then,
remember.
good. Oops. I messed up. I can't believe I did that. I'm so silly. The first line that I drew, I didn't do the -2. I did a +2. Oops. I'll fix it and I'll do it in pink. I did it backwards. See that? Silly me. So this pink is what it should have been, right? And then the new one that we're doing has that y-intercept of -1 and a slope of 3/2. So I'm going to go up 3 over 2, and there's a point there. And then where else? It kind of looks like it's going to intersect in between there. So let me go ahead and graph it. Okay. So the two lines are, let me do the one in yellow and the one in pink, but not this blue one that doesn't have a highlighter. So ignore this one, okay? We're just going to look at the yellow one and the pink one. So those intersect right in here.
Incredible on the way out.
Can I white it out? Is that what you said?
Incredible out.
Can I do what to do it out?
Incredible out.
Scribble it out. Oh, sure. I can scribble it.
No way I don't get confused.
Yeah, I understand now. Sorry about that. Okay, so this spot right here is where the two good lines are intersecting, okay? That intersection point is the solution to the system of equations, okay? So the intersection is the solution to the system of equations, and we usually write that as a pair of coordinate points, like so. This one, the problem with this one is that it's not whole numbers. Do you see how it's kind of in the middle of the line right there? It's not right on the corner of the grid square. So it's not what you call a lattice point that has a whole number. It's kind of close to 1, 0, but it's not exactly 1, 0. So anyway, it would be great if we knew the coordinates because then we could know the solution. But this one has decimal values for those coordinates. So that is one of the tricky things about doing what we're learning today, which is solving a system by graphing. So let's look on the notes. We're going to solve systems of equations by graphing. And to do that, you basically graph your two lines together. Oops, that should be the word. Together on the same graph and find their intersection. Okay, so let's look at the things that can happen. There's 3 different ways that that can happen. I'm going to make 3 little sketchy graphs here, okay? So the first thing that can happen is your 2 lines can intersect, just like what we had happen in the bell work. Your 2 lines can intersect, and the coordinates of the intersection are the solution. Okay, so that's the thing that happens most of the time when you're trying to do these problems. But there are some other things that can happen. Your graph could show 2 parallel lines that will never intersect. And when this happens, there is no solution because the lines are parallel. Oops, that's a L, not a T. Parallel. Over here, this one we just did a moment ago, we call those intersecting. And then the last thing that can happen is you can have 2 equations that when you graph them, they end up being the same line. And if it's the same line, then you have infinite solutions because every point on the line is a solution.
I remember.
Yeah, and this has a fancy name, coincident. So it looks like the word coincidence, but it's called coincident. Okay, so we learned a little bit about that in Algebra 1, but we also talked about it a little bit again last year. We learned those names, intersecting, parallel, coincident. So let's do some examples together, and then we'll do some practice problems. So my first, even though this says example 2 here, I'm going to make this one our first one, and I'm going to do this. I'm switching the numbers. So here's our first example, y equals, yep. So my y-intercept is at 1, and my slope is, for this yellow one, my slope is -2, right? So down 2 over 1, and it's that line there. Okay, so there's my line. And then my second line is not going to be so easy to graph. Can you tell me what is wrong with that second equation that's going to make it a little bit more difficult?
Oh, we gotta get everything on the other side.
Good. So if we move this 3x term to the other side of the equation,
Yeah.
good work.
Or,
Awesome. So really, when you think about it, if you have to move a term like this 3x to the other side, you could think about it as though you're just going to move it over and change the sign, right? Because it's always going to disappear from the side you're moving it away from. And the side you bring it to is going to have the opposite sign when it gets there, right? So it was a 3x, and now it's over here, and it's a negative 3x. Okay, so let's graph this one. It has a y-intercept of 7. 3, 4, 5, 6, 7. That's 7 right there. I think I'm going to double count that. Yeah, that's 7. And then we have a slope of negative 3. So let me put that over 1. And I'm going to start at the 7. Yep. Good. Down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1, and 3 over 1. I think I might have, there it is right there. Okay. So now I'm going to draw that line. So it might be hard for you to see it, but it's actually happening right there at the bottom of the graph. Do you see it? Where my pen is? That's where it happened. So the coordinates for that point are, let's look. 1, 2, 3, 4, 5, 6 squares over and all the way down to the bottom. So the coordinates 6, comma, let's see, there's negative what?
9.
You're close. This is 4 here, right? This is 4 squares to this spot. And then this is another 4. So 4 and 4 is 8, and 3 more, that's 11. Negative 11. Okay,
Yeah.
Let's do another one. So this other example that we're going to do is kind of like that, but it's a little bit different. So we're going to graph. Now this is the same first line that we have on the other problem. So I'm going to graph it really fast. Negative 2x plus 1 is right here. Okay, there I go. Okay, there's that line. And then we have this second one that has that same problem where the y is not isolated. Now, do you remember how when I was on example 2, or, well, I called it example 1, but when I worked this problem with you, we talked about if you want to bring a term to the other side, you can change the sign when you bring it to the other side, right? So I can look at this equation that we have right here, and I can say to myself, well, if I bring this negative y to the other side, won't that make it positive? Which is kind of what I want. I want a positive y.
Yeah.
And then if I bring this 3 to the other side, that would make it negative. So I'm going to rewrite things that way really quick. I'll have 2x minus 3 equals y. So I switched these two things and I changed their signs when I moved them over, okay? The 3 came here and it's negative, the y came there and it's positive. And now I'm just going to rewrite this. I'm going to write it as y equals 2x minus 3. I mean, I really don't have to rewrite it, but maybe I feel better with it looking like an mx plus b. So I have -3, and then my slope is 2. Oh, I already hit the other line right there, didn't I? That first point that I did for slope when I went rise 2, run 1, it hit the other line. So I already have the answer right there. That happens sometimes when you do these. It's like you get the answer when you're trying to plot the second line. So the coordinates at that point right there are over 1 and down 1. So what would I write for the coordinates? Nice job, Connor. Good work. Okay, so we're going to do a couple more practice problems like that. These first ones are super easy because the y is already isolated. So can you pick one of those that you want to do? Do you want to do number 1 or number 2? Okay, so let's do number 1. We have, you tell me what to do.
Go up 1.
Go up 1.
Yeah.
Are you telling me about the slope when you said go up 1?
Yeah.
But you're supposed to put something else on the graph first.
Why in that?
Right. So what's my y-intercept?
Go right 20.
Okay, good job. Now what do I do?
Go up 1 over 4.
Good work. Up 1 over 4. Okay, so I'm going to plot that line. And then
Go down 20.
okay.
Go up 7.
Up 7
Over 4.
over 4. That puts me right here because I go up 3, 4, 5, 6, 7, and over 1, 2, 3, 4, and I'm right here on the other line. So what are the coordinates of my intersection?
Negative.
My intersection point? That's right here, isn't it?
Probably.
Can you say that again?
Probably. Probably.
Positive what, though? Positive what? What number? Oh, is that number hard for you to say? It's 4. Good. 4, 4. All right, now we're going to do these other two at the bottom. Both of these are problems where you have to isolate your y to get your y equals mx plus b. And I'm just going to see if I can get it to focus because it's a little bit blurry. That's a little bit better. Okay, so what if I zoom it out a little and then try to get it? Oh, well, I don't know why. It's just not, it's not focusing well, Connor, but can you read that that says -6 equals -6y minus 9x? Okay, good. So I'm going to rewrite this equation, this -6 one, over here where we have some room to write things. -6 equals -6y minus 9x. Okay, so you remember how we talked about rearranging your equation and putting terms on the other side. So what would you like me to move to the, well, what terms do you want me to move? Tell me which ones.
Y.
Okay, so if I bring that over here, it will become a positive 6y. And then what else do you want me to move?
9.
The 9x, that can stay there. We should move the -6.
Negative.
So if we do that, then we'll have this, because the -6y came to the left side and changed the sign, and the -6 came to the right side and changed to a positive 6. Okay?
Divide.
Divide by what number?
Yeah.
Good work. So that gives me y equals, and then you can reduce -9/6 if you divide both of those numbers by 3. So how many times does 3 divide into 9?
We
Good work. And then 6/6, that's a 1. So now, oops, I lost track of my x. This has an x right there. So this is -3/2 x plus 1. I'll rewrite it better. -3/2 x plus 1. That's our first equation. So I'm going to put that on the graph, okay? So positive 1. Now, how do I handle this -3/2 slope?
go down. We almost.
Good work. Okay, so down 3/2. And then we have this line. Okay. Now we have to work with the other one, right? So let me, I'm just going to switch colors to make it easier for you to tell which one is which. And I'm going to write that second one, 12 minus 2x equals -4y. Okay, so which terms do you want me to move?
More.
Okay. Really, I could move everything, Connor. I could bring this to that side and those to the other side. So that would make a positive 4y, a positive 2x, and a -12, right?
Divide.
Okay. That's a y. I know it doesn't look like a y, but that's a y. So y equals, what does 2/4 reduce? What does that reduce to if I divide them both by 2?
4.
Good work. 1/2 x. What is 12 divided by 4?
3.
Good work. And I'm going to keep my minus sign. Okay, so now we're going to plot that line. So we have -3, and then we have a 1/2. So I'm going to, good, up 1/2. Oh, I just hit the other line, didn't I? So there's my point of intersection. So what are the coordinates of that intersection point?
-3.
Right here.
-3.
2. What's
Negative. Negative.
good? 2, -2. You got it, buddy. Awesome. That was tough, I know. All right, so let's go over here to number 4 now. So we're going to do that same rearranging thing that we did on the previous problem, okay? So what terms do you want me to move on this top equation?
Why?
Okay. Now, if I only move the 2y, if I only move this, then,
Move it up.
oh, sorry. Okay. If I only move the 2y, I'll still have the 6 on the wrong side. So I'm also going to move that. Okay. Because the x is really the only thing that's where it belongs. So when I move the 2y, that will be positive 2y. And I'll keep the x. And then when I move the 6 from this side to the other side, it will become positive 6.
No
Now,
why?
good. So now I have y equals, and I have to treat this like it's a negative 1/2, because don't you have 1x if you have just x? So
Yeah.
that's negative 1/2 there. And then 6 divided by 2 is, yep. So this is our equation, negative 1/2 x plus 3. Tell me how to plot it. Awesome.
No.
Good work, Connor. Nice, nice job. Okay, now we have to do the other line. So I'm going to switch colors and copy the other equation. So the other equation says 0 equals 3 minus x plus y. So which terms would you like me to move?
No why?
Okay, so if I bring the y to the left, it becomes negative. So I can't have this negative sign on the y, right? Do you remember that you can just divide by -1 and it changes every sign in the equation?
Yeah.
So we would have positive y equals -3 plus x. Or if I reorder that, that's x minus 3. Right?
Yeah.
Because -3 plus x is the same as x minus 3. Okay, so let's put that one on the graph. So I have a y-intercept, -3, you're right. And then what is my slope? Not just x. You have to think about the number that is the coefficient of the x. Good. So my slope is 1. So what do I do for my slope then?
Go up on the
Good job. And when I do that, it's like going diagonal through the squares. Okay. So what is the solution to this system? What are the coordinates of the intersection point?
probably one. Oh.
That's right, but you have it backwards. It's 4, 1.
Oh man.
Yep, that's the right answer. Okay, so we are done with talking about graphing to solve a system, and we're only halfway done with our time. So I'm going to press stop on that recording, and then we'll talk about if we want to do some more in a minute, okay? All right. Okay, so now we're doing the second day of notes. So this is what everybody else is going to start learning tomorrow. This is learning about solving system by substitution. Substitution, okay? So substitution means that, remember, you're going to have two lines and you're looking for a solution where they have the same values. Well, for substitution, what you do is you look at your original problem. Let me cover up all the extra stuff there. You look at your original problem and you notice that you have a variable that's isolated, and this whole part here can be equal to x, which means that 5 plus y can be a replacement or a substitute for x. So then what you do is you put this 5 plus y as a substitute for x in the second equation right there. So it'll be 2 parentheses 5 plus y minus y equals 12. So that's what it says over here. 2 parentheses 5 plus y minus y equals 12. Then you would have to distribute this 2 across the parentheses. So you would have a 10 plus 2y for the distributed part, right? And then you have, yeah, you do. I knew you would. Okay. So that is called substitution. And when you get the answer to the first variable, then you take it and you plug it into one of the original equations to get the second variable. So now you have a y value and an x value, and you can write them together. If the x is 7, it goes first, and you write it down like it's a pair of coordinates in parentheses.
Yeah.
So that's how we do it. So let's do our examples. There's not really a lot of notes. Instead, it's mostly working problems. So this first example here, it says solve using substitution, which is the method that we are learning today. So we need to look at our two equations and we need to think about, do we have a variable isolated? And we do. We have y isolated. So that means 5x plus 3 can be used as a replacement for the y right here in my other equation.
Yeah.
So I'm going to write x plus 2 times 5x plus 3. And then I go back and look, that's equal what? Nice work, Connor. Now what do I do? Good. So I have x plus 10x plus 6 equals 28. Now I can take care of this right here, right? Now what? Good work. So I'm going to go back to this original equation of y equals 5x plus 3, and I'm going to go 5 times 2 plus 3. So that's 10 plus 3. Good work. And then what?
I don't know.
You do.
No.
There you go. Yeah, you write it as coordinates. And we are done with that problem. Super, super easy. Now, there's one other style of these problems. So you notice how the first one we did only one variable was isolated in one of the equations and the other equation did not have a variable isolated. But when we look at this second example here, in both of these, y is isolated. So 5x plus 1 means the same thing as y, and 13 minus x means the same thing as y. So if you do, it doesn't matter which one you choose. You can just say, okay, well, y is the same thing as this, so I'm going to go to the other equation and put it in place of y. And now you have this. So basically what's happening here is since these two expressions both equal y, then the two expressions equal each other.
Yeah.
Because y has to equal itself. All right, what would you like me to eliminate?
1.
Okay. I'm sorry, I lined that up in the wrong place. I should have written it under the 13. Okay, now what?
Combine one.
I can't combine like terms because they're on opposite sides of the equal sign.
Oh.
But if I want to put the x's together, can't I just move this over to the other side like we were doing earlier?
Well,
Good. So when I move it over, it will become a positive x. And it will be gone from here. So I'll have 6x equals 12. Now what?
no, my.
Okay.
No, plug it in.
Okay. So I'll use the top equation just because it's easier for me to read.
You left.
Yep. Now what? Yep. Coordinates. Done. So that is super easy peasy lemon squeezy. Now we're going to do some more practice with it. We're going to see how good we can get. So I have this practice sheet and we're definitely going to have to like rewrite it and zoom in and stuff. But I want to pick some that don't come out super nice because I want some of the answers to be fractions and stuff. So let me look at this for a moment and make that happen. All right, let's try this one here. And I really don't know that it's going to come out. I'm worried that I want to make sure you can handle it when the problem has decimals and fractions and not just whole numbers. So I want to work some of these that are at the bottom. I want to work these 3 at the bottom because I think that there's a pretty good chance that those will come out to have decimals or fractions. So I'm just going to rewrite. I'm going to do 7, 8, and 9 here with you. And I'm going to rewrite them bigger just so that they'll be easier to read on camera.
Yeah, I will be ahead.
What did you say? Ahead in a way, yes. But you'll see. We're just going to be doing a lot of practice over the next 2 days. So it's hard to say until we see how well you're doing, okay? So notice how in both of these equations, hold on, let me check something first. Oh, I should have done a different one first. Let me pick a different problem first. I'm sorry. Hold on a second.
Why?
Because that one's one of the toughest ones on the page, so we have to do a different one first. Okay, let's do this one first. So which one do I use as the substitute equation? The first one or the second one?
No. second number 2.
Yeah, the second one. So we're going to let this be a replacement for y, right? So let's rewrite this as x plus 2 times 3x minus 14 equals 14. Okay?
This number
Okay. 2 times 14 is 28. Now what?
plus
Okay. Plus 28? Okay. 14 and 28 is 42.
number
Okay.
for the flip play of the
Put it in place of the x. Yeah. So I'll do the top equation. So 6 plus 2y equals 14. Minus 6. 2y equals 8.
number
Y equals, good. So our solution is whole numbers 6 and 4. Okay, so that one was not bad. Now let's look at this one. We're going to do number 6 now. 2x minus 3y equals 13. 2y equals x minus 7. Okay, here's the next one. So now, do you see how the second equation is almost isolated for y? And if I wanted to, I could divide by 2 on the second equation and get the y isolated. But there is another thing I could do. Look at that second equation. Couldn't I isolate the x? If I go and move the 7 over, and wouldn't that isolate my x? So that's what I would do. I'm going to go plus 7 here and eliminate that. And now all of this is my substitute for x. Okay? So I'm going to go to the top equation and make it my substitute for that x. So basically, we're taking this whole idea of substitution and we're having to figure out how to isolate the variable when it's not already isolated. So let's put this 7 plus 2y in place of that x right there. So we'll have 2 parentheses 7 plus 2y minus 3y equals 13. Good. Good work.
Come on.
So what's 4y minus 3? Yeah, that's just 1y. So just y, really.
My
Now what would you like me to do?
no. Mom.
Right. We'll put the -1, the -1 in place of the y. So that means it can go in either equation, remember? So I can put it here or I can put it there. It doesn't really matter. So I'm just going to use the top one. 2x minus 3 times -1 equals 13. So -3 times -1 is +3. So 2x plus 3 is 13. Two x equals 10.
Never. Why?
Let's do 5, -1. Now you remember that we can actually check to make sure that these are correct. So we can go to our original equations and try to replace the x with 5 and the y with -1 and make sure that it's true. So I'm going to go do that now. 2x minus 3y equals 13. That would be 2 times 5 minus 3 times -1 equals 13. So that's one that we're going to check. So that's 10 plus 3 equals 13. Check. Now that I just checked the first equation, now I'm going to check the second equation. So the original equation was, the original equation was 2y equals x minus 7, and I rewrote it to be this thing, but it was originally 2y equals x minus 7. So I'm going to write that. So now I have 2 times -1. Sorry, let me move my paper. So if y is -1, I'm going to put that -1 as a replacement for this y. And then if x is 5, that goes here. 2 times -1 is -2. What's 5 minus 7? -2. So this is right. So we know that we have the right solution because when we replaced those values, 5 and -1, into both of equations, it came out true. Okay, here is problem number 7. This is the one that we were going to do earlier, and I said, oh, wait, we need to do a little bit of other stuff first. Here it is. This is your challenge problem. Do you notice how there's not an isolated variable anywhere? So basically, we have to look at it and we have to make a decision about which one do we think would be the easiest one to isolate. And sometimes there's really not a great answer to that question because sometimes it's going to create a fraction or decimal no matter what you do. So let's just look at what we have. If we wanted to isolate this x or this y, either one of them, we would have to take the term that we don't want to have there and bring it to the other side of the equation. And then after that, we would have to divide by the number that's the coefficient on the y or the x. Okay. Same thing with this one here. I can take this 6y term, I can bring it to the other side, and then I can divide every single term by that 2 to get the x by itself. So I'm going to do that with the second one, and I have a silly reason why. Because the first one already has a decimal in it. I don't want to deal with extra decimals because I know when I divide that decimal by another number, it's going to make more decimals. Okay. Instead, I'm going to try and work with this one. And I'm going to work with isolating the 2x. And I have a strange reason why. It's because I know that if I isolate the x, then the last step will be divide by 2 to get rid of the 2. And that is easy to do. You can divide by 2 with any number in your head. You know, you could just take half of it in your head. If I was to try and isolate the y term, the last step would be divide by 6, and I can't do that in my head. So my silly reason for isolating the x is because I'm lazy and I want to divide by 2 because I know that will be easier. Okay, so I'm going to take, let me use a different color highlighter. I'm going to remove this term from that side, and when I bring it over to the other side, it would become a negative 6y, right?
Yeah.
So now I have the equation 2x equals 15 minus 6y. Now what do I do to isolate that x? I divide by 2. So I have to divide each term by 2, and then that makes this a 1x, or just x. 15 divided by 2 is 7.5, and 6 divided by 2 is 3, and that's a minus sign, so I'm going to write minus 3y. Okay? So now I've got this equation, which is really just I took the one here and I kind of rearranged it to get x by itself, right? So all of this work represents the second equation. So I'm going to work with this one and then the original top equation. And that's kind of like, now that's going to be the system that I work on, okay?
Yeah.
So this is my replacement for x, and I have to put it into this x.
Yeah.
So negative 3 parentheses 7.5 minus 3y. And then I go back here and I write minus 2y equals 5. Oops, that's a minus. Okay. You are so right. I have to distribute. So when I distribute negative 3 times 7.5, 3 times 7 is 21, and 0.5 times 3 is 1.5. So it's like 21 and another 1.5. That's 22.5 when I do 3 times 7.5, and it's negative. Now I have to do negative 3 times negative 3y. Good, 9y. Now this was a minus sign, so minus 2y equals 5.5. Can't I combine my terms? Yes, good. So negative 22.5 plus 7y. Good. So now I get 7y equals, and when I add 5.5 to 22.5, I get 28. Now what? Good work. Perfect. All right, next step. Okay, so we'll take the second equation to get the second variable. I'm just going to use the second one. You remember how I told you earlier I have silly reasons for some of the things that I do? Do you remember how we had to create this isolated x equation here? I would rather use the second equation when I go to solve, just because, and this is going to sound silly, but this is an equation that I haven't changed anything about it. It's one of the original equations. So those are usually safer to use. Negative 3x minus 2 times 4 for y equals 5.5. Negative 3x minus 8 equals 5.5. Plus 8, negative 3x equals 13.5. Good. So I think that you get you get 4.5 for that. And it's negative because this was positive and that was negative. So negative 4.5. And now negative 4.5 comma 4 is our solution. Okay. That was a tough one, wasn't it? It had some decimals and you had to isolate your variable and just a lot of work. Okay, so I'm going to stop there. Because it's 7 o'clock. Okay, so this is about what you call linear inequalities. So we did graph these on your first quiz where you had to put one inequality on a graph, but this is a system of linear inequalities. So you're going to have two graphs together and the shading is going to overlap. Okay, so let's look at this. If we graph this y is less than 2x minus 1, we have a y-intercept of -1, and we have a slope of 2 over 1. So up 2 over 1. So we have this graph. I need to grab my ruler. Now, do you remember what I need to do for my line? Connect, yes, but dotted or solid?
No. No.
Dotted, yeah, dotted. We only use solid for equals, right?
Yeah.
Okay. Do you think this should be a shade above or a shade below? Oh,
Above. No, below.
less than is below. Okay, so below.
Below.
So we would have it look like this. Okay. So that's what we learned about in 1.1, 2 quizzes ago. So basically, if you want to graph one of these, you have to isolate y. Then you have to plot your y-intercept. Use your slope, dotted or solid, question mark, and then shade, right?
Yeah.
And you can also test a point, right? You could test 0, 0 for true or false. And we shade it if it's true, right? And we make it, if it's false, then we don't shade it. Okay. So right here, if you have just less than or just greater than, we make a dotted line to show that the line is not included in the solution. It's sort of like an invisible line that's not included. If it's less than or equals or greater than or equals and it has the equal sign underneath it, we use a solid line to show that the line is included in the solution. It's part of the solution, okay? And then right in here, the reason that's there is to say shade where true, right? You shade it where it's true. So one side of the line is true and the other side of the line is false. So for this graph, I can pick any point in the shaded zone and it will be true, and any point over here would be false.
Yeah.
Okay. So what if it's a standard form? Standard form is the ones where the X and Y are on the same side. So that's this way. So let's do one of those. So what if we had this? Well, we could isolate Y, right?
Yeah.
So we do minus 2x And we would have 4y is greater than or equal to negative 2x plus 12. And divide by 4 on each term. And that gives us y is greater than or equal to negative 2/4 x plus 3. I could even reduce that negative 2/4 to negative 1/2 if I wanted to.
Yeah.
So then when I go to put that on my graph, I have a y-intercept of 3 and a negative 1/2 slope. Good. Do I want a dotted or solid line?
No.
Good. And do I want to shade this above or below? Yes, good. Okay, so that is that. Now, what if we had a system of inequalities? Well, a system of inequalities would have two of these together on the same graph. So what if I put the one from earlier together with this? That would be what a system would be like. You know, a system always has two equations, right? So a system of inequalities would have both of those. So let me put the earlier one here. This is the one we did up above. So I'm going to put this one on the same graph with the other one. So it's 2x minus 1. So negative 1 was the y-intercept, and the slope was rise 2, run 1. So it was like this, and it had a dotted line. And then it was less than. So that's why it was dotted. And when it's less than, you shade below, right? So I'm going to shade. Now, it's kind of confusing when the line looks almost vertical. It's a little bit confusing what's below, but this is the below. This is under the line here, okay? Now, the solution to the system of inequalities is going to be everything that's in the overlap where both of them are shaded together at the same time. So that would just be the part here, right? Where you can see both colors together. Okay. So I'm going to zoom that out just a little bit to make sure you can see the whole thing. So this is what our lesson is about. And that's not too difficult, really. You just have to remember to put both of them on the graph together. And this is this curly brace, these fancy parentheses. Remember how those are always, when you have a system of equations, you have that holding your two equations together, right? So you'll see that they call this a brace. You'll see a brace, and then you'll have two inequalities together with a less than or a greater than symbol. And you'll put them both on the same graph, and you'll be really careful about your dotted lines and solid lines in your shading. Then you'll look for where the shading overlaps. Now, when you get to your test, they might ask you questions like, is the following point in the solution? Okay, so I'm going to list some points, and I want you to tell me which ones are in the solution and which ones are not. So, hold on. I got to think of some good ones because I want to trick you. Haha. I want to see how good you are. Okay, so first of all is, okay, is negative. I didn't mean to write that. 0, -1 in the solution.
No.
Good. Is 2, 1 in the solution for the system?
Yeah.
Nope, it's not. It's only in the shading for one of the inequalities, not for both of them. Okay? Because 2, 1 is right there, right? So it's only in the orange. We need it to be here.
No.
Is 4, 1 in the solution?
No. Yeah.
Yeah, it is. 4, 1 is right here on the solid line that's on the edge of all the shading, right? This is on the edge of the overlap part. So this, any point on this is part of the solution because it's solid, right?
Yeah.
It's the solid edge of the overlap region. So anything on this edge would work. What about if I pick the point over here? Is this part of the solution for the system?
No.
No, just for that one inequality. Okay. What if I pick this point right here on this boundary line? Is it a yes or a no?
No.
No. Why? You're correct.
No. No. Oh.
It's because this is a dotted line. Is that what you're saying?
Yeah.
Yeah. So it's no because it's dotted. It was a yes on the other one because it was solid there. Okay. What if I say this point right here that I'm pointing to? Is that part of the solution?
Yeah.
Yes, it is. Good. Okay. You might have a test question like that when you take your quiz, okay? That will ask you, you know, which ones are part of the solution and which ones are not. So now that we talked about that, I think you'll get those right. So don't fall for the trick. Don't pick anything on the dotted line, but if it's on the solid line, it's okay. As long as it's the part where it overlaps, right?
One.
Okay. So those are pretty easy to do, but let's just look at this problem right here. I want to do this one that's the graph. Okay, so the instructions say a student has graphed the system shown below and they made a mistake and we have to find their mistake, okay? So let me show you the problem. It's way over there, so I'm going to recopy it close to the graph so we can look at it. So it says x minus y is greater than or equal to 3, y is less than -2, x is greater than or equal to 1. Okay. So it actually has 3 lines in it. It has y is less than -2 is part of it. Do you remember if y equals lines are vertical or horizontal?
Oh.
If it has just y, it's horizontal. So this
No.
That's what?
No.
Oh, that's what you said. Oh, okay. So here's their dotted line at y is less than -2, and they have shaded below. So it looks like they did this part correct. X is greater than or equal to 1. That's going to be vertical, right? So if you look at how it's counting, each square is counting by 2s. Do you see how this is 0 and then this is 4. So it's going 0 to 4. So if this is 2, then halfway through the square is 1. So here's their x equals 1 line. It says x is greater than or equal to 1. Where are the numbers that are larger than 1? Where should they shade that, on the left or the right side?
Why?
Yeah, so it's messed up because they shaded the left, didn't they?
Yeah.
Yeah, it's white right here, and they shaded that side. So this is the part that they messed up, is this right here. And now we can also check this line. So this line at the top, you see how they have x and y together? Let's isolate the y. So if I isolate the y, I would bring, let me bring x to the other side. And I'm just going to rewrite this over here where I have room. So they have x minus y is greater than or equal to 3. And then if we want to move the x over, we would have negative y is greater than or equal to negative x plus 3. Oh, shoot. There's a bug in here, and I was trying to squash it, and I turned off the light. Okay, and then we have to divide by negative 1 to get the y by itself, right?
Yeah.
So if I divide by negative 1, I have to remember to do what?
No.
Flip my symbol. I
Yeah.
have to remember to flip my symbol. Okay, so now this is the other line. So it has a y-intercept of negative 3. That's right there, because it's each square is worth 2, so halfway there, that's 3. And then a slope of 1. So you would go up 1 over 1, up 1 over 1, up. Yeah, that looks like they did that right. So the only mistake they made was the x is greater than or equal to 1 line is in the wrong place with the shading. They shaded the wrong side. They did a less than or equals instead of a greater or equal. So now that there's 3 regions shaded, I'm going to try and see what we can do to check your understanding, okay? Is the point, well, that point that I darkened right there, is that part of, oops, right there, is that part of the overlap for all 3 shaded regions?
Yeah.
Yes, it is. So that is part of the solution. What about the point 4 comma negative 4? Is that in the solution? 4 comma negative 4. Is that in the solution?
Yeah. No.
No, it's not, because it's in one shaded region, but not all of them, right? What about the point negative 8, negative 4? Is this in the solution right here?
No.
No. What about the point 1 negative 8? Is 1 negative 8 in the solution?
No.
1 negative 8.
Yeah.
Yeah, it's right on the line, but it's part of the solution, right? Yeah. So it gets more and more. If they give you 3 lines, it's very tricky because you have to have just in here, right? This is where all 3 of them are shaded, right?
Yeah.
Okay. So let me think. I really think that we've talked about everything we need to. I know you know how to graph those lines, so I don't want to do a whole bunch of those. So, Oh, this is a great question for you, Connor. I love this question. It says, you have to write a system of inequalities for this graph. So you have to write two inequalities to match this graph that you're looking at. That's a great question.
Oh,
So first of all, do you see that they're counting by twos on the squares?
yeah.
Yeah. So this spot right here, this y-intercept, to me, the lower one, that looks like a -1 right there. And then it looks like if I come down to here and I go over to there, that looks to me like it's down 1/2. Let me try. Let's look in a different spot on the graph. Oh, no, it's not down 1/2. I can't even figure out the slope. It's hard to read this graph. Let's use the points, okay? So see how they gave us these coordinates are -4, 2 for this point?
Yeah.
And then for this other point, these coordinates are 3, -3. We can use that to help us find out the slope, okay? Boy, this is a tricky question. So to get the slope, we could use the slope formula. So I'm going to write m equals y2 minus y1 over x2 minus x1, okay?
Yeah.
So I'll go y2, and I'll put 2 minus -3. And then for the x2, I'll go -4 minus 3. Do you remember if you subtract a negative, it's really adding? So you have to do plus, plus. So that is 5. And this is -7. So that's the slope, -5/7. No wonder we were having trouble. Now, we were right about it having a y-intercept of -1. That was correct because it's right in the middle of the square. So if I want to write, if it was an equation with an equal sign, it would be y equals mx plus b. But it's not. It's an inequality with a dotted line. So we're talking about this line right now, okay? So did they shade above it or did they shade below it? This one right here.
Above.
Right. So what kind of symbol should I have? Nice job. And then my slope is -5/7 that we just figured out with the slope formula. So -5/7 x. And what's my y-intercept again? It's right in the middle of the square, and each square is 2. So that's -1. Okay. Now we have to work on the other line. So the other line is this one right here. Okay. And it has these points, -4, 1, and 2, -1. Okay. So we're going to use those. Let me highlight them real quick. It's so hard to read this on the screen. So we're going to use those two for our slope. Okay.
Yeah.
So m equals y2 minus y1 over x2 minus x1. So that's going to be, if I make this my x2, y2, and I make this one on the left my x1, y1, then I can go -1 minus 1, right? Now what do I do for my x's? Good job. So then this -1 minus 1, that's a -2. And minus the negative is like adding, so that's 6. And I can reduce that by 2, and it will be negative 1 over 3.
Yeah.
So that's the slope. Now let's look at the line again. Let's try and figure out. It's hard to see the y-intercept, isn't it? It's above the other one, though. It's halfway above the other one. So what's half of 1? 1/2, right? So I think it's at negative 1/2. Is it shaded above or below on that line? Did they shade above that line or below that line? They did above on this one. They did. Here's how I know. I know they didn't go above this one because see, it's white right here.
Below.
Yeah, below. So that's a less than because it's dotted and shaded below. Our slope was negative 1/3, then x, and then our y-intercept is negative 1/2. Ooh, that was tricky. That was not easy. That was a good question, wasn't it? That was a good challenge. Okay. So now all we have left for today is I want to go through a few problems with you, and I'm just going to use a piece of scrap paper for this. I want you to tell me what's the best way to solve the problem. And your choices are substitution or elimination. Okay, so that's the name of the game. Would you use substitution or elimination on each one of these questions? Okay. Now, is it easier for you to just say S or E? Are those letters easy for you to pronounce?
Yeah.
Okay. Or you could even say sub or I don't know. I can't think of a short word for that. Okay. So I'm going to put some on the screen and you're going to tell me what's the best way to do it. Okay. So let me find it. Here we go. What would you do for this one right here? Is this a substitution or an elimination?
Elimination.
Good job. All right. What about Ooh, okay. How about this one? Is this the same one I just showed you? It's not, is it? Oh, it is.
Yeah.
Oops. It is the same one. Okay. All right. I have to rewrite it on another piece of paper. Just a second. What if we had okay. What if you had this one that's right here? Can you read that? Is that substitution or is that elimination? Good. Okay. What about this one right here? This number 7 one. Substitution or elimination? Really, this one's a bad problem altogether, but I would say elimination. Here's why. If you bring this 30 to the other side where the 0 is and make it negative 30, won't this line up with this and this will line up with that? And we can do elimination. Okay?
Yeah.
Okay. That was a tricky one. All right. All right. What about this one here? Number 5.
Elimination.
Yeah, I think so too. Because if you wanted to do substitution, you would have to isolate a variable, right?
Right.
But if somebody told you that you must do substitution on this problem, which variable would you eliminate? Do you think the first equation is better or the second one for eliminating a variable and getting one of the variables by itself?
Number one.
Nope. Number two, because look,
Yeah.
yeah, you would use this one. You would isolate this y, and it would be better for that. Okay.
Yeah.
Because we could just bring this 7x to the other side and go 7x minus 25 equals y. And now we have y isolated. See how easy that was? And now you could do substitution with this one now because you could use that for your sub, right? If you tried to do substitution and isolate a variable on the top equation, aren't you going to have to divide by the coefficient in front of the variable?
Yeah.
Yeah, so that's not as good. All right, let me give you one more. Oh, this one's too easy. I'm trying to find one that is. Oh, I know what else we should do. I have one more thing we should talk about. Okay. We have to talk about how to write the equations for word problems, okay? So I will do two. And we're not actually going to solve it. We're just going to make the equations for it because you will have a word problem on your test. And I want to make sure you can do the equations for them, okay? So I'm going to put all of these on screen. These are all the practice ones I have for right now. So let's read number one together. John paid $34 for 2 algebra and 3 geometry books. He paid $36 for 3 algebra and 2 geometry books. What is the cost of each book? All I want to do is just write the equations. I don't want to solve the system because we've done plenty of practice with solving the system. I just want to make sure that you're okay with writing your equations. So it was $34 for 2 algebra and 3 geometry. So what if I let algebra books be X and geometry books be Y, and the total is 34. So 34 equals 2X plus 3Y. Okay. Now, can you tell me what the second equation would be? $36. Mm-hmm. Good. What number in front of X? I couldn't understand. Three?
Yeah.
Okay, 3X plus.
Y.
Good job. Okay, now let's talk about the next pair. The sum of two numbers is 14. So I can let the two numbers be X and Y. X plus Y equals 14. If one of the numbers is doubled, so double is times 2, right? So I'm going to go times 2 with one number. The sum, that's what happens when you add. The sum will become 22. So I have to go times 2 with one of the numbers. Which one would you like me to double?
Okay.
No, not that, like the X or the Y. Okay, so I'll write 2X plus Y. Now I've doubled X and their sum is now 22. So this equals 22. Okay? So let's read through it and make sure it all makes sense to you now. The sum of two numbers is 14. So that's where we got X plus Y equals 14. If one of the numbers is doubled, so you told me to double the X, The sum, so I still have to add it to y, will become 22. So that's why it equals 22. Okay?
Yeah.
All right, last one. Peter invested $450 in insurance and stocks. He put $50 more in insurance than stocks. How much did he invest in each? Oh, goodness. Okay. So we can let the amount of insurance be X and the stocks be Y. So the amount he put into the X plus the amount he put into the Y equals a total of 450. He put 50 more in the insurance than the stocks. The insurance was the X, the stocks was Y. So he's got 50 more on X than he has for Y. So X plus 50. No, did I do that right? Well, it's okay. X plus 50 equals Y will work. So one of them is 50 more than the other one, is what that says, right?
Yeah.
Yeah. So it's not, I think I kind of did it backwards, but it's okay. So, because the way I have it written now, I'm saying the insurance plus 50 is the stocks. And that's kind of backwards because it says 50, well, this is saying it's the insurance is 50 more than the stocks. So I did it backwards. If I take the stocks and add 50, then I get the insurance, which is 50 more. Do you see what I mean by that?
Yeah.
Yeah, it's kind of confusing, but it makes sense now because when you look at it, you're taking the smaller one and adding 50 so it can equal the bigger one. So we have 50 more in the insurance. So it's the bigger one. Okay, so those would be your two equations. All right. So let me go back to the first one because I think I forgot to reread that one with you. $34 for 2 algebra and 3 geometry. So we wrote 34 equals 2x plus 3y. $36 for 3 algebra and 2 geometry. 36 equals 3x plus 2y. All right. So we're better about writing equations now, right?
Why?
All right. Let's just look at all three of these and let's talk about would we do substitution or elimination on each one. So in the first group, would you do substitution on this or would you do elimination on this?
No.
This one right here,
No. It will what?
right? Because you do elimination whenever they line up and you can add them, right? But the problem is when you look at this, do you see how there's no number I can multiply 2 times to get a 3? And there's also the same problem here. So what you would have to do with this is you would have to multiply both equations. And we didn't do any of those last night. So I think it would be a good idea for us to work this problem together. Okay. So if I wanted to work with these variables here, I'm going to have to multiply both of them. I'll have to multiply the 2 times the 3 and the 3 times the 2. And then they'll both be 6s.
Yeah.
So the top equation is going to go times 3, and the bottom equation is going to go times 2. And once I do that, I'll have 3 times 2x is 6x, and 2 times 3x is 6x. But I want to have one of them be negative, don't I?
Yeah.
So I'm going to do times negative on just one of those numbers. So now I'm going to distribute this 3 all the way across and write my new equation here. And distribute this negative 2 all the way across and write my new equation there. Okay?
Yeah.
So 3 times 34 is 90 plus 12. So that's 102 equals 3 times 2x is 6x. And 3 times 3y is 9y. Good job. Now we have to distribute this one. Negative 2 times 36 is negative 72. Negative 2 times 3x is negative 6x. And negative 2 times 2y is negative 4y.
Yeah.
And now we're ready to add those. So this makes a 0 with the 2 6's. 102 minus 72 is 30. And 9 minus 4 is 5.
No what?
Good. So we'll go divide by 5, and we get y equals 6. And then we plug back in. I'll use this one. 34 equals 2x plus 3y. So I'm plugging in 6 for the y in the 34 equals 2x plus 3y equation. 34 equals 2x plus 18. If I go minus 18, then I have 16 equals 2x. Divide by 2. Good job, 8. So that means that, nice. So it's $8 for algebra and $6 for geometry. Yeah, you're right, 8,6. But when it's a word problem, you can say it in terms of the things that the variables represent. So since X represents algebra books, I can say it's the price of the algebra book. So it's $8 for an algebra book. So that's another way you can do the answer. Okay?
Yeah.
Okay. When I look at this number 2 problem, do you think I should do substitution or elimination?
No, no. You will wait.
You're right, elimination, because the X's line up and the Y's line up and the numbers line up. Well, unfortunately, the Y's don't have opposite signs, do they? But we can change their signs. So I'm going to take a marker and change all of the signs on the second equation. Change every sign. So now all of those are negatives because before they were all positives. X minus 2x is negative 1x. Y minus y is 0. 14 minus 22 is negative 8. Divide.
No, why?
Oh, what? Where?
-1.
This one here? That's not right?
You follow mine.
Do you mean right here?
Yeah.
So I did 1x minus 2x, and I got negative 1x.
Okay, I got you now.
Okay, good. So now if I divide off all of these negative 1s, I have x equals 8. And then I need to go back to my original equation, which was x plus y equals 14. So 8 is the x. So 8 plus y is 14. So y equals 6. And then if I put it in terms, yep, you're right, 8,6. If I put it in terms of the situation, they say The sum of two numbers, blah, 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 blah. What are the numbers? So you could write a sentence that says, the numbers are 6 and 8.
Yeah.
All right. So I think we've done enough. Okay, Connor, I'm going to go ahead and press stop because it's 7:20. We've been on. Okay, so this lesson is reviewing some of the basic things that you learned about functions in Algebra 1. And a function is just a different way of thinking about a relationship between X and Y. So we're going to get into the notes on that in a moment, but kind of as an icebreaker, we're going to think about this. This is kind of a question that you had to answer in Algebra 1. Are these relations functions? Yes or no? So you see, first we have this thing. It's called a mapping diagram. And these are like your X's or your inputs. And these are your Y's or your outputs. So when X is 1, Y is 2. When X is 2, Y could be 3 or 4. And when X is 3, Y is 5. So this one, do you have a guess? Do you think it's a yes or a no?
Yeah.
It is a no. It is a no. I'll talk about why in a second. All right, let's look at this one. This X goes here, this Y goes there. Each one of these X's goes to exactly one Y. So this is a yes. Let's go backwards to this one. So you see this? This X right here goes to two different Y's. That's why it's a no. All right, and then let's look at this. Each X goes to a unique Y. So that's a yes. All right, and then the way you do it with a graph, you're looking for each X to have only one Y. So when X is -4, there's nothing. When X is -3, there's just that 1 point. When X is -2, there's nothing. When X is -1, there's just that 1 point. At 0, there's nothing. At 1, there's just 1 point for that X. So if we keep going through this whole graph, there's only 1 point for each X. And the way that they tell people to test that is using a vertical line test. You remember doing that? And sometimes teachers will say you could just run your pencil along there and think, can my pencil hit more than 1 point? And it's only hitting 1 point at a time. So this passes the vertical line test. So yes, it's a function. Does this pass a vertical line test? Yes, because everywhere it goes, it hits only 1 point. Does this pass a vertical line test?
No.
It actually does. Look, everywhere I go, I'm only hitting 1 point. So we'll see what a no looks like in a moment, but these were all yes. Okay, so here are our notes, and this is a big old sheet of notes. So our learning target is to be able to define functions, like is it a function or not, then to be able to evaluate a function, and to be able to find the domain and the range. And domain is a fancy name for the X values, range for the Y values.
Yeah.
Okay. There is a whole lot of vocabulary associated with functions. First up here, we have ordered pair. And I think you remember that ordered pair just means like X comma Y in parentheses. A mapping is this thing here. This thing here is called a mapping. Okay. An input-output table. I think you know what an input-output table is. This is an input-output table.
Yeah.
And then, you know what a graph is, vertical line test we just talked about. Relation is what you call it if it's not a function. It's either a function or it's a relation.
Yeah.
Functions are more special. Domain for the X's, range for the Y's. Function notation. Function notation is just when you use F parentheses X instead of Y. So it's instead of Y, right? It means the same exact thing.
Yeah.
And the way you say it is F of X. independent variable is your x, and your dependent variable is y, your f of x, if you're writing it in function notation. All right, here's some notes. A relation matches a set of inputs with outputs. A function is different from a relation because for every x, there is only one y. For every x, there's only one y. And it doesn't work in reverse. It's just for every x, there's only one y. So I'm not going to say for every y, there's only one x, because that doesn't have to be true. It's just for every x, there's only one y. We can test graphs for this using a vertical line test. We talked about that a moment ago. Equations can be written using either x and f of x or x and y. We already talked about that. Domain is the set of inputs or x values. Range is the set of outputs or y values. And function notation is a way of stating the rule in terms of the independent variable. I think that statement will make more sense after we do a word problem. So this last thing here, I'm going to come back to it later after we do a word problem, and then it will make a lot more sense. Here's an example of something that does not pass the vertical line test, because if I put my vertical line right here, I'm going to hit it 1, 2, 3 times. So this fails the vertical line test.
Yeah.
And since it fails the vertical line test, then it is not a function. So I'm going to put this triple dot like this. This means therefore not a function. Okay.
Yeah.
So let's start some examples together then. This first one here says, determine whether each representation describes a function. So if x is -1, y is -2. If x is +1, y is 5 or 12. So for this x, there are 2 different y's. But for every x, there's only one y. So that is a no, not a function. So we're going to look at each one of these x's on this mapping diagram next, and we're going to figure out, does it point at only one y? When x is 2, it's only 5. When x is 4, it's only 4. So I look at each one of them and I look to see, is it only pointing at one y? And this is a yes. Now, Connor, do you see how right here there are 2 different x's pointing at 5? That's not a problem. That's okay, because it says for every x, there's only one y. When x is 2, it's 5. When x is 6, it's 5. That's okay. Each one of those has only one y. It doesn't say anything about for this y, there could be only one x. So it's all right for this to happen. You can't have double arrows like, where'd that other paper go? Goodness, I lost it. You can't have a double arrow that starts at x and lands on 2 different y's. But it's all right to have double arrows pointing at the same y. Okay? So those are 2 different things, aren't they? This is a no, because it's the same x with 2 different y's. This is a yes, because it's the same y with 2 different x's, and that is okay. All right, next we have coordinates. So if you have coordinates, you're looking for every x to have a unique y. When x is 0, y is -1. Do I see any more x's that are 0 in this group? No. So if x is 0, there's only one y. Then I've got x is 1, and it's this. X is -1, and it's that. -2, and it's that. +2, and it's that. So since every single one of these x values is a different number, then it doesn't even really matter what the y's are. For this to not be a function, they would have to give me another pair that has the same exact x with a different y. And they didn't do that. They gave me every X different. So of course the Y's don't matter. So this is a yes, because every X is different. Down here, here's another one. This one is a no, because all of these X's are the same with different Y's.
Yeah.
I'm writing when X equals 1, Y has more than one value. I don't know if you can read my handwriting. It's a little bit sloppy there. Okay, so let's look at example 2 now. This one is a word problem. And I told you earlier that I said I promised that I would explain about independent and dependent variables with a word problem. So let's look at this word problem. The relation between the length of the femur, F, the bone from the knee to the hip joint, and the height of an adult woman, H, is modeled by this function, H of F equals 2.3F plus 24. In the following ordered pairs, the first coordinate is the femur length and the second coordinate is the corresponding height in inches. So I should write that down. So it's the femur here and the height there.
Yeah.
Femur here, height there. Okay. Find the unknown measure in each ordered pair. So let me go back to that thing in the notes that I was reading earlier. It said, function notation is a way of stating the rule in terms of the independent variable. What that means is, like when it's f of x, x is your independent, right? So your dependent variable depends on the independent one. I need to say that again because it's a confusing language thing. Your dependent variable depends on what the independent one is. So I'm saying y depends on what x is. Your output depends on your input. So when they write this rule, they're saying h parentheses x. They're saying the height depends on the femur, right? When they go h of f is 2.3 f plus 24. They're saying the overall height depends on the length of the femur. Okay? It's kind of like the height in terms of the femur is 2.3 times the femur plus 24, if you really want to think of it that way. Okay? So that's what I meant earlier when I said about independent and dependent variables. It's a way of helping the person see what's the input and what's the output when you write it in function notation. All right, so here they're giving us this ordered pair of 13n. So the f is 13 and the height is the letter n. So I can write, when I write h of f, I can write 13 where the f goes. So I'm going to write h of 13. So for this one, I know my input and I can work it out. Because whatever's in the parentheses, this is the rule that you do to it, right? So this says do 2.3 times that number plus 24. So we're going to go 2.3 times that 13 input plus 24. So I'm going to work that out on paper because I don't have my calculator with me. So I need 2.3 times 13, right? Yeah, we're just going to work this out together. You can watch me and make sure I don't mess up. 3 times 3 is 9. 3 times 2 is 6. And then 1 times 3 is 3. And 1 times 2 is 2. And now I have to add. And I have 2.3 up here, right? So I have 1 decimal space. So I have to hop it back 1. So I got 29.9. And then I have to go plus 24. So I'm going to go plus 24. and line those up. So 9 and 4 is 13 carry 1, and 1 and 2 is 3, and 3 and 2 is 5. So I get 53.9. So the height of a woman with a 13-inch femur, her total height is 53.9 inches.
Yeah.
All right, so that's the first one. So the second one, oh wait, they had an N there, didn't they? They had an N. So I'm going to write N equals 53.9. Okay, inches. Because they told us the units were inches. Okay, now we're going to do the next one. So the next one says, we don't know the input, but we know the output. You want me to box that answer? Is that what you were saying?
Yeah.
Sorry. Okay. So now we know the output, but not the input. So I have to, instead of, I can start with my original equation, which is H of F equals 2.3 F plus 24. I can start with that equation again, but this time I know the output is 16.2. And I have to solve for the F, the input. Oops, 24. Oops. So I can go minus 24 here. And then that gives me 7.8, and it's negative.
And then why?
Yep, let's divide by 2.3. It looks like that does not come out to a whole number. This doesn't seem right. This seems like I made a mistake. I guess it's very small, like a baby or something. Yeah, 16.2 inches long is a baby. Because when babies are born, they're like, you know, that's actually a pretty small baby. So, okay, I was feeling bad for a moment. All right, I'm going to do the division because, again, I don't have my calculator with me, but 7.8 divided by 2.3. And it's negative, too.
You want to do it?
You have a calculator there?
Oh, my God. Oh,
We have to do negative 7.8 divided by 2.3. You can leave the negative off because I can just put a negative on the answer.
what the number?
It's 7.8 divided by 2.3.
Negative 9.
Okay, thanks, Connor. So that doesn't even make sense, does it? How can you have a negative 3-inch femur? That's a weird problem. I need to, that's kind of crazy. I wonder why it's like that. Oh, well, I got that from a textbook. So it's kind of funny that it's like that. I'll look it up later and see why they have it messed up. But that's a good example of sometimes when you have a math model equation, it only works for a range of values. And then at some point it doesn't make sense anymore, because we don't have negative lengths on our bones. So when it gets to be a certain size, it just doesn't work anymore. All right, let's look at this third example. So what the math that we did was good math. It's just that the equation doesn't work when the numbers get to be too small. For this third example, it says, determine whether each graph describes a function. So could we do a vertical line through more than one point is the question. And do you see right here, I can hit 3 points if I do my vertical line right there.
Yeah.
So this is not a function. Is there anywhere that I could do a vertical line and hit more than 1 point here on this second one?
Yeah.
So let me just drag my,
No.
so this is a yes, right? Is there a way to hit more than 1 point here? This would hit more than 1 point, wouldn't it?
Yeah.
So see, when I hit more than 1 point, that's when the X is 1, I have 2 different Y coordinates. I have 1, 0 here, and I have 1, 4, right? So
Yeah.
when X is 1, I have 2 different Ys. So that's why it's a no, because I'm supposed to have 1 Y for each X. All right, let's look at example 4. Example 4 says, state the domain and range for each function. So you remember your domain is your X values and your range is your Y. So when you're talking about domain, you're talking about this horizontal X axis for domain. And when you're talking about your range, you're talking about the vertical axis. All right, so if I look along this yellow horizontal X axis,
And what that only is doing color.
what do you want me to do?
Not orange.
The orange?
Yeah.
What?
It's white.
It's too light? You want it darker?
Yeah.
Okay. How about like this? Is that better?
Yeah.
Okay. So on the yellow, that's my horizontal axis, right? If I look and I'm trying to see how far it spreads out. So I just look for everywhere I see a point. This is the farthest one to the left sideways. And this is the farthest one to the right, isn't it? So the X coordinate of this point is -3. And the X coordinate on that point is +3. So my domain is starting at -3. And then it also includes -1, 1, 2, and 3. So when you have points, when you have points that are separate points that are not connected like that,
Yeah.
you can just give the set of X values. So for the range, it would be the set of the Y values. So my lowest Y value is the one closest to the bottom here. And this is -3. Then I have one here at -2. Then I have one at 1. And then I have one at 2. So those are all my X values.
Yeah.
Okay.
Yeah.
All right, let's do the next one. So we're looking along our x-axis and we're looking for how far it spreads from side to side. So as I go as far as the curve shows, it's got this little arrow here. And up there, there's an arrow. So those arrows, when you look at the way that those lines are going, you see that they're tilted. They're really curves. They call them curves. It's tilted. It's not going perfectly up and down. It's not perfectly vertical. It's got a slant to it. And it's going this way. So eventually it's getting farther this direction, right? It's not going this direction as quickly as it's going upwards, but it is continuing in this direction. And the same thing down here, it's continuing in this direction. So that's going from negative infinity to positive infinity. So for my domain, we're going from negative infinity to positive infinity. And that's how you write it. And then let's look at the range. It's going all the way down to negative infinity, all the way up to positive infinity. So the range is really the same thing, from negative infinity to positive infinity. All right, and now let's do this last one. So as I look at the horizontal spread of it, I notice there are arrows here and here. So it's going in this direction forever, which is towards negative infinity, and in this direction forever, which is positive infinity. And then for my range, you'll notice when you look vertically along the x-axis, you're looking for that vertical spread, you can see it doesn't go any higher than right here, this notch that I'm making. That's the highest it goes, right?
Or
And then the bottom, it's not going any lower than this.
yeah.
It's staying between -1 and +1. So watch how I write that. -1, comma 1. So this is something called interval notation. And what it really means is when you put a boxy corner, it means you're including that number, like a greater than or equals to. It's including the number. And this is like less than or equal to. So basically it's saying I'm going to start at -1 and I'm going to include that number. And then I'm going to keep on going and include every number in between there all the way up to +1 and include that number too. Up here where I wrote the domain from negative infinity to positive infinity, I was saying, I'm going to start at negative infinity, but I can't put a box around that because infinity is not an actual number that you can get to, that you can stop at. It just keeps going. So that's why they put the parentheses on it, because you can't really include it since it's not actually a number.
Yeah.
Okay. All right. So now we have some practice that we're going to go through together, okay?
What about the what example?
What about the what? The last example?
Number.
Oh, there is one more. I missed it. I'm sorry. You're right. Example 5 down there. Right there, right? There it is. It says f of x is 3x squared minus 5. Find f of -3. So that would be f of -3 equals 3 -3 squared minus 5, right? So I'm just replacing the x with -3.
-9.
No, because -3 times -3 is what?
9.
Right. So this should say 3 times +9 minus 5. And then that is 27 minus 5, which is 22. So f of -3 is 22.
Yeah.
And that's really just another way of saying this answer. X comma Y. If X is -3, Y is 22.
Yeah.
Okay. So now let's look at our practice. I think we're still going to finish on our at our regular time of 7 o'clock. Oops, I went too far with my paper. So let's see. So up here, I do not want to make a mapping diagram and ordered pairs and a graph on the coordinate plane for this data set. But what I do want to do, so I'm skipping number 1, I want you to do number 2. What is the domain and range of this data set? So what is the first thing is we have to decide what the input and the output are. So which row do you think is the input, the year or the gold medals?
The year.
Good. This is my X and this is my Y. So that means these are the domain. So the domain, remember how when we had the graph with just the points on it here, we had to list them in these fancy curly brackets. That's what we're going to do. So we're going to write the domain, and then we're going to use these braces. Those show a set of numbers. And then you just list the numbers with commas between them. So we need to list 1988, comma, 1992, 6, 2000. I'm running out of space. 2004, 2008. And then we close our brackets. So there's your domain. Okay, let me put it where you can see everything. There. Now we have our range, which is just the list of all of the Y values. You're right. You're right. But here is a very picky thing. They like you to put them in order. So which one is the smallest number?
Y.
Good. Then what? And I don't have to say that number twice. I can just list it one time. Then what? And now, and there you go. Okay. So a weird thing happens because since they had the same Y twice for 2 different years, then we have a shorter list for the domain than what we had for the range. But that's okay. That can happen. All right. Number 3, determine whether each relation is a function or not. So the rule is for every X, there is exactly one Y. So do you think this is a yes or a no? For every X, there is only one Y.
Yeah.
Good. That's right. What about this one, number 4? For every X, there is only one Y.
Yeah.
Which one is the issue with that? Which one is the reason it's a no?
Oh no.
It's when X is 2, Y has more than one value. That's why. And then let's look at this one. For every X, there's only one Y. Is every X pointing at only one Y?
Yeah.
Yes. So this is a yes. Okay. Now we're going to check these using the vertical line test. So for the vertical line test, we have to figure out if we draw vertical lines, will it hit only one place? So is each one of these lines only hitting one point? Yes, they're only hitting one point. So yes.
Yeah.
What about this one here? This next one, what is this? Is this yes or no?
No.
Right. We had that earlier, I think. All right. And then I know we saw this for the domain and range earlier, but we didn't see it for a function question. Each one of these lines is only hitting once. It's only 1 point for each one. So this is a yes. All right. So I know that's really easy, but your brain remembers if it keeps getting practice, right? All right, let's look at this. Number 9, it says evaluate each function for the given value of x and write the input x and the output f of x as an ordered pair. So that's actually like the thing we did on that example here, where we worked it out and then we wrote the answer as an ordered pair. Remember doing that? Okay, that's what they want us to do. Now, we don't have to do all of these. Let's just do, how about we do 2 of them?
Yeah.
All right, so we'll do number 9 and number 11. So I'm going to get a different piece of paper because this doesn't have enough room for me to write on. So for number 9, it says F.
Will you wipe the hell by no? How will we get the work out?
That was a mouthful. I didn't hear part of that. So what, when we do what when we work it out?
Will we get the work out and wipe it by the palm?
Oh, goodness. I don't understand.
You wipe the hell by the palm.
Oh, right here on this page. Oh, now I understand what you mean. Yes, of course I'll do that. No problem. All right. F of x equals negative 3x plus 2. And they said for x equals 3. So we're going to write f of 3 equals, and then we need negative 3 times 3 plus 2. So what's negative 3 times 3?
9.
Mhm.
Negative 9.
Right. Yes, negative 9. So this is negative 9 plus 2. What's negative 9 plus 2? You are doing so much better with your negatives these days. That's really good. So f of 3 is negative 7. So when we write that as coordinates, how should I write it? Awesome job, Connor. You even told me to put the comma. Good job. All right, so the next one is f of x equals 5x minus 22. X equals 12. Okay. Oh, okay. Yes, sir. I'll box it in. I forgot. Okay. F of x equals 5x minus 22 for x equals 12. All right, so here's our new problem. They said x equals 12. So what do I have to write next? Of 12 equals good.
9. Wow.
Good job. Okay, and then 5 times 12 is? Did you forget what that is? 60. 60 minus 22. So 60 minus 22 is going to be 38. So f of 12 is 38. And how do I write it as an ordered pair?
No. Oh, yeah.
There you go. Nice job. Okay, so we've got 12, 38, and we are done with that. Okay, so the next group of problems says, ooh, these are tough. This says write a function rule, which is basically a way of saying write the equation to model the cost of renting a truck for one day. Then evaluate the function for the given number of miles. So basically, they want you to read through this, write an equation for it, and then plug in this number and find out the answer for this.
Yeah.
Okay, so a daily rental is $19.95, but the rate per mile is 50 cents additional. So they want this to be like a y equals mx plus b type of equation where this is the y-intercept and this is the slope that gets multiplied times the x, the 50 cents per mile.
Yeah.
So it's going to be
Y equals
yeah, exactly. So if it was that way, it would be like 0.50x plus 1995. But they want it in function notation. So instead of the y, we have to write an R for rental, I guess. So that'll be like, here, I'll write it over here. R of x equals 0.50x plus 1995. Okay, so there's our function. And then they want the miles traveled to be 73. So we're going to go R of 73 equals 0.50 times 73 plus 1995.
and you the
Can I do what? Oh, do you want me to box in my equation?
no.
What?
No. Make
Make it a what? An M for miles?
no.
L?
No.
A M.
No.
A N?
No.
I think you should text it to me.
Make it
X? Make it a... Oops. Are you texting me?
Yeah.
Good, because I'm really lost. Make it a... Are you saying M for miles? Keep it as a F. Oh, you mean like F of X. Oh my gosh. I feel so silly. I understand now. Yes, you can do that. Sometimes people change that letter and sometimes people like F's better. That's fine if you want that to be an F. There we go. It's F. I'm sorry, Connor. I should have realized. Okay, now it makes sense. So F of 73 and then 0.5 times 73 is 36.5.
Yeah.
and then we have to add 1995. So that's going to be 56.45. So that's $56.45.
Yeah.
So we have to give the answer. I'm just going to put it right here because there's not much room on the page. I'm going to say it's 56.45 or 73 miles.
Yeah.
And then they want us to do it again with a different one. So now this one says the daily rental is $39.95 and it's 60 cents per mile. That's going to cost a lot more. Look at the difference. They're charging like twice as much money per day, and they're charging more per mile too, 10 cents more per mile. So it's going to cost a lot more. All right, let's do this.
Why eagle?
60x plus.
999.
Good job. And then we have to rewrite that as f of x. So f of x equals 60x plus 39.95. So now we have to do that with an input of 48 miles. So 0.60 times 48 plus 39.95. So 0.60 times 48, I'm going to work that out really quick for you. 0.60 times 48. So that is 28.8, 2880. And we have to add on $39.95, which is really like adding 40 and taking off a nickel. So I'm gonna add $39.95. And I get $68.75. So f of 48 is $68.75. So that's going to be $68.75 for 48 miles. Okay, we did really well with that. I like those problems because they were a challenge. We need a challenge. All right, find the domain and range and determine whether it is a function. So first off, are these functions? Yes, that is, and no, that isn't. So this is a yes, and this is a no. It's not a function. On the yes one, this arrow is pointing to negative infinity and to positive infinity. When you look from side to side, it's spreading forever, right?
Yeah.
For the domain, which is the horizontal spread, it's going negative infinity to positive infinity. For the range, which is the vertical spread this way, I can see these arrows are both going up to positive infinity, but isn't it stopping there at the V, at the vertex right there? It's not going below that number. So that is one below the x-axis. So that's at -1, right?
Yeah.
So it starts at -1. Is it including the number -1? Like, yeah, it is. So I have to put a boxy bracket, and then I have to put -1, comma, and then it keeps on going forever up to positive infinity. So now I put a positive infinity. And do you think I should put parentheses here or a bracket?
What?
Parentheses.
Yeah.
Always put parentheses on the infinity because you can never, ever get to that number. All right, let's look at the other one. So the domain is how far this thing spreads sideways. And this is stopping right here. It doesn't have arrows. Okay. So what is the number right here along the x-axis? What is the x value along the, I meant to say the y-axis, I'm sorry. What is the x value all along the y-axis there?
Yeah.
Right
Yeah.
here. It's at 0, isn't it? Because it's
Yeah.
right in the middle. So for the domain, the smallest number is 0. Is it including things at 0? Yes, they're right there on the axis. They're included. So since they're included, we're going to put the boxy bracket. Then we include the 0. And then we put a comma to show that it's continuing from that number until, and what's the highest number it gets to along the x-axis? Sideways. Where does it stop at?
Wait.
This point right here is as far as it's going. So that's 1, 2. It includes that number at 2. So we put a boxy corner to include that number.
Yeah.
Then for the range, I need to know the smallest number vertically. So when you look at it up and down, what is the lowest value that it has?
Negative.
Good job. And is that number included? It's touching that number, right? It's touching there, so it's included. So we put a boxy corner to include it. What's the highest number that it gets to? Good. And we also put a boxy corner there to include that number, okay?
Yeah.
All right. We are doing so awesome. So we are going to do, oh, okay. Do you remember me telling you earlier when we did the example with the word problem and we came out with the negative number and I said sometimes things just don't work out? I found out why it didn't work out because this is the rest of that word problem. See it? This problem here is the same problem we had earlier. And I just copied and pasted the numbers, but look, it was this one. So it was typed wrong. It's supposed to be 56.2. But on the other paper, I had it as 16.2. So that's why it was messed up. That was supposed to be a 5. And I printed it wrong. So let's do that over, okay? We'll do a do-over with that one. So 56.2. So we're going to do h of f is 2.3f plus 24. And then we're going to go 56.2 is the output. So where does that go? Does it go here or does it go there? If it's the y value. Does it go on the left or the right?
Wow.
Good. So 56.2 equals 2.3f plus 24. Now what do I do?
Right.
Good. And then that's going to give me 32.2.
The one.
Good work. And then I think that you get, oh no, I'm going to have to work that out. You have your calculator where you can reach it? It's 32.2 divided by 2.3. I think you might get 14. Yeah, I just figured it out, Connor. It's 14.
And
Is that what you got? Yeah.
no, and that
You want to check it?
yeah,
Okay, the number was 32.2. Divided by 2.3.
yeah,
You got 14?
yeah,
Good. So that's 14 for the inches of the femur. 14-inch femur for a 56.2-inch tall woman. There we go. So we just did that problem. All right, that's it. I'm going to press stop on your recording because we've been working for an hour. And we are completely done with all the practice. We did such a good job tonight. All right, let me see.
yeah.
Okay, so this part of target 2.1, this is day 2, so it's 2.1b. This is about performing function operations. So operations like add, subtract, multiply, divide. Those are what we're going to be doing with our functions. So what that means is you're going to have two different function equations that you're going to either add together, subtract from each other, multiply together, or divide by each other. Okay? So let's start looking at that. These notes up here, this is just about the way it's going to be written. This says f plus g in parentheses of x means to do f of x plus g of x. So what that means is if they write f plus g together times of x, then you have to do your f of x function added to your g of x function. If they write f minus g, then you're going to take your f of x function minus your g of x function. If they write f times g of x, you're going to do your f of x function times your g of x function. And then we're not going to do division. We're going to skip that just because it gets too complicated. We'll do it later. Okay? So here's example 1. It says f of x is 4x minus 1 and g of x is 2x squared plus 3. Find f plus g of x. So since there's a plus sign right here, then that means we are going to add together the f of x formula and the g of x formula, okay? So that's going to be, here's my f of x, and the other one is my g of x right here. We're just going to add those two things together, okay? So we're going to go f plus g of x equals 4x minus 1, that's the f of x, plus 2x squared plus 3, and that's the g of x. Now, those parentheses that I put on there, it was just so you could see the two separate chunks, but those have nothing to do with multiplying. We're still going to combine like terms wherever we can. So we have to combine these like terms but those are not like terms. So then we'll have f plus g of x equals, I'm going to put my highest exponent term first. So that's this one, 2x squared. That will be my leading term. Then plus 4x. And then I'm going to combine -1 with 3 and get 2. Okay. So all we did was just add the two formulas together. All right. So next, at the bottom, it says, let's evaluate f plus g of 3. So we already have a formula for f plus g of x up there. We can just plug in 3 to this formula. So that's going to be 2 times 3 squared plus 4 times 3 plus 2. Right?
Yeah.
So then, using your order of operations, you have to do this exponent first. So that's a 9 when you do 3 squared. And 2 times 9 is 18. So that's 18 plus, and then 4 times 3 is 12, and then plus 2. And then we're just going to go left to right. 18 plus 12 is 30, and 30 plus 2 is 32. So f plus g of 3 equals 32. It's different, isn't it? It's something new that you haven't done with that before.
Yeah.
All right, let's do the next one. So the next one says, find f minus g of x. So now our operation is subtraction. So order matters when you subtract, right? So we have to make sure we put the f function first, then the g after it, right? So I'm going to put the f first, which is the, let me write the label first. For my answer, the label is f minus g of x. And then on the formula side, on the right side of the equal sign, I'm going to put the f of x first, then my minus sign and the g of x. 4x plus 8 minus, and I'm going to put the parentheses, 2x minus 12. Okay, now why do you think my parentheses matter? Why do I need my parentheses? Kind of. That negative sign is like a -1 distributing over this, isn't it? It means you're going to subtract the 2x and you're going to subtract the -12, right?
Yeah.
So that's why these parentheses really matter. Okay. So this equals, I can actually just distribute that negative if I want. So I'm going to take away my parentheses and distribute that negative. -2x and positive. Good, good. And now we're going to start combining like terms.
Oh, yeah.
So what is 4x minus 2x?
Ooh, yeah.
Good. And then we have to combine +8 with +12.
Volume
8 and 12 is just 20. Are you hearing a tapping sound? Connor, do you hear a rattling noise or a tapping noise?
No.
You do or you don't? Yes or no?
No.
Okay. I'm hoping the recording is not messed up. I hear it on my side. Huh. I'm going to try something, okay? I'm going to...
Oh, I know what
What is it?
in my control.
Oh,
In my man.
okay. Well, it's going to be part of the recording and it's going to be kind of a little bit loud. So yeah, it doesn't sound bad now. It went away. That's good. So let's go on to f minus g of 7. So here's our f minus g of x formula, right? So now I can take this formula that's for f minus g of x and I can plug in 7 for the x. So that's going to be 2 times 7 plus 20. And then that is 14 plus 20. And that's 34. So f minus g of 7 is 34. Okay? Whew. You're doing great. This stuff is pretty strange, isn't it?
No, why we do what?
No, not at all. Okay, next. Now we have this one. Now, I said that we didn't have to do division, but we do have a division example here. So I'm going to go ahead and start it, and I'm going to see how it goes. So this is g divided by f of x. So I'm going to go with the g function in the numerator and the f function in the denominator. So that is how you would write it. And then you would not be able to simplify this because there's 2 different things in the denominator and they're not like terms. So you really can't do anything except leave it like that. But to evaluate g over f of 2, we would do 5 times 2 over negative 3 times 2 plus 2. And that will be 10 over negative 6 plus 2. And that is 10 over negative 4. And if I work that out, that's negative 2.5. So g over f.
It wasn't bad.
It what?
It wasn't bad.
It wasn't. It's easy?
Yeah.
Oh, yeah, that one wasn't a bad problem at all. It was a good one. Okay, so let's keep going. Here's the last one. This is a multiplication one. See, this is a times dot, right? All right, so now we have to do the f function, 4x plus 8, times the g function, 2x minus 12. We have to multiply those times each other. Now this is going to be a little bit of work. Do you remember what it is like to multiply those?
No.
It's like distributive property. You have to do 4x times this and times that.
Yeah.
And then you also have to you do remember that's good. You also have to do the 8 times this and times that. Okay, so that's going to be for the 4x times the 2x, that would be 8x squared. And for the next term, you've got 4x times negative 12, so that's negative 48x. And then you have 8 times 2x, so that's positive 16x. And then the last thing is 8 times negative 12, and that's negative 96. So now we have to combine our like terms. So what is negative 48 plus 16? That is negative 32x. And I'm going to carry down the 8x squared, and I'm going to carry down the negative 96. And that's my answer. That is f times g of x. That's the formula. Now they want us to find f times g of negative 3. So I can go equals 8 times negative 3 squared minus 32 times negative 3 minus 96. So negative 3 squared is 9, right? 9 times 8 is 72. Negative 32 times negative 3 is positive 96. And then I'm going to carry down this negative 96. So all of this here, this negative 32 times negative 3 gave me this number here.
Yeah.
And, you know, all of this was the 72. So now I'm just carrying down the negative 96. But 96 and negative 96 cancel each other out. So I'm left with 72 for my final answer. So f times g of negative 3 is 72. Now, I want to show you something else, and it's kind of interesting that that's not the only way to do this. If they give us the number, see right there, they gave us the value that they wanted us to substitute in, then you don't really have to start with this whole formula up here. Instead, if all you have to do, if they don't ask you to find the formula in the problem, if all they ask you to do is this part here, and you don't have to find the formula to answer a question, then you can actually just plug in the negative 3 from the beginning. So I'm going to start the whole problem over, and I'm going to show it to you in a different way really quick. And I'm going to let you decide what you think about all that, okay? So let me get the blank page that I need real quick. Okay, here we go. I just needed extra paper because it's going to take some room. So to do what I just said, you would take your f of x formula, which is 4x plus 8. And see, we're trying to do f times g of negative 3. So that means we could find out what f of negative 3 is. And we can also find out what g of negative 3 is. And then we just have to multiply the two answers together. Okay? So f of x is 4x plus 8. So f of negative 3 would be 4 times negative 3 plus 8, right?
Yeah.
And then that would be negative 12 plus 8, which is negative 4. So f of negative 3 is negative 4. The g of x formula was 2x minus 12. So I'm going to write that down here, 2x minus 12. And I'm going to substitute the negative 3 for the x.
Oh.
And then 2 times negative 3 is negative 6. And negative 6 minus 12 is negative 18. So that's the g of negative 3. So now to do f times g of negative 3, I have to go this answer times that answer, okay? So f times g of negative 3 would just be the f of negative 3 times the g of negative 3. So that's negative 4 times negative 18. And you know what 4 times 18 is? 72.
Yeah.
And negative times negative is positive. So we just got the same answer as earlier, right? So this is the work I had to do to get that answer without having to do it with just the formula. Now, I don't know that one way is necessarily better than the other. For this way, we had to do distributive property with these two binomials and work out a big formula and then plug the number in. For this other way, we had to plug the numbers into both things and find the answers and then multiply the answers together. So the way I wrote it, it makes it look like a lot more work, but really you can do 4x plus 8 on a calculator and go 4 times -3 plus 8 on a calculator and get an answer really fast. So if you were somebody who was fast with a calculator, this would be a good way. But if you're trying to write less, this way is less writing, I guess. It just depends on the problem, really. So I wanted to let you know that that's an option, that sometimes if it's very difficult to work out the formula and you don't really need the formula, if all you need it for is to find a number evaluated for that input, then sometimes you don't even need to do the formula. So let's go ahead and do some problems now. So there's a lot of problems on this paper. We can't do all of them, but we're going to just pick certain ones. And the test will have problems that look a lot like this, where they will give you two equations and then they tell you exactly what they want you to do, okay? So let's start. For this first one, on number 1, it says, here are my two functions, g and h. Find g minus h of x. So what should I write first? Huh? Say what? Oh, you said the g, didn't you? Okay. So -4x plus 4 goes first. Then what? Then minus. Oh, I forgot my parentheses. Then minus. Plus 3. You got it. Okay. So now we have to start doing that. We have to figure that problem out. So here you go. I'm going to distribute the negative to the second set of parentheses, and I'm going to drop the first set, okay? So that will be -4x and -3, right? Okay. Good. So what do I get if I combine -4x with -4x? No, it's not multiplied, it's just added. -8x. Yep. Okay. So -8x. Now I'm going to combine +4 with -3. So 4 minus 3. Yep. Plus 1. So then I put my label on the front end of my answer. G minus h of x equals -8x plus 1. And that's it. Okay? So this time we're not evaluating because they did not give us a number here. They just gave us an x. So we're really just coming up with a formula and then we stop. We don't do anything after the formula. All right, let's do the next one. Let's do number 3. This says g of x is -3x to the third plus 4x squared. H of x is 2x. Find g times h of x. So we need to write our g function first, right?
Yeah.
Okay. So that, yeah, you're right. -3x to the third plus 4x squared. And that's going to be multiplied times the h function. So what should I put to make sure I do that correctly?
Well,
Parentheses. Now what?
well,
I need the other parentheses, and this is a times dot. So what goes in the other parentheses? Good. Now what?
no,
Good. And I'm going to multiply using distributive property because there's a plus sign inside of here. Okay.
yeah.
So I'm going to do it kind of like 2x times this and 2x times that.
Yeah.
So let's start here on the left. 2x times negative 3x to the third. When I go 2 times negative 3, what will I have? Good. And then what about my x term? What will the exponent be on the x? Four, because this is a 1 and this is a 3. And when you multiply, you just add the exponent. So that'll be x to the 4th. All right, now what about the other terms? So we need a plus sign and we need to do 2 times 4 is 8. Good. And then it's going to be good. And that's my answer. Now I need to put my label out front. So g dot h of x equals. I didn't leave much room there. There we go. You good? Does it look good to you? Yeah, I think we did a good job with that. Okay, let's go to the next one. I'm going to keep going just down this column because these are pretty good. This one says g dot h again, so that's another multiplication problem. So we're going to write the g function first, 3x plus 2 times the h function. And what do I have to do?
Combine.
Not combine. I'm just going to be multiplying. Oh, are you thinking distribute? Is that what you were trying to say?
Yeah.
Distribute. Right, like that. So 3x times x.
Well,
No, 3x squared. Because you're adding the exponents, but you're just multiplying the coefficients. So 3 times 1 is 3, and then x times x is x squared. Now 3x times negative 2, negative x. Next, what are we going to put? Good, plus 2x, and then 2 times negative 2. Good. Now we have to combine our like terms in the middle. What will that be? Good job, Connor. So we have 3x squared minus 4x minus 4. And our label on the front is g dot h of x equals. Boy, this is some algebra 2 going on in here. This is some serious stuff. All right, next. Let me find the next good problem for us to do. Ooh, I like these. These are challenging. You're going to like this. Look at this one. G plus 3h of x. Come again. That's crazy, isn't it? And do you see how weird that is? That's pretty crazy. So there's a 3 here now. What the heck is going on with these people, right? They're writing some really difficult stuff in there. So what that means is you have to go 3 times the h function.
Yeah.
So you're going to have to take the x plus 3 for the h, and you're going to have to go 3 times all of that, right? So 3 times h of x would be 3 times the x plus 3. So that would be 9x plus 9, right?
Yeah.
Goodness. And then for the g parts, that will just be the g function. So you're going to take this 9x plus 9 and add it to the g parts. So here, let me color code this. Here's my g of x, right? There's my g of x. And my 3 times h, I have that going on in yellow. So that is all of this, right? There you go. We're going to add that together. So let's combine like terms where we can. The only place you can combine is the 2 and the 9. Because this x term has an exponent of 2, and this x term has an exponent of 1, right? So negative 3x squared plus 9x plus 11. That is g plus 3h of x. Whew. Man, they are challenging us tonight. All right, what now? Let's see what else we have to challenge us. What about...
You forgot the F on it.
What, right here?
Yeah.
Oh, you don't have to write a 1 if it's a 1, because everything is to the first power. That just means you have one of those. But thank you for reminding me about it. Okay, let's do one more subtraction one just so I can make sure that I don't mess anything up for you. So how about this number 4 problem right here? Just want to make sure that you remember all the important things, okay? So this says h minus g of t. It's a little bit blurry, isn't it?
Yeah.
I'll just rewrite it. So they've got h of t is t cubed plus t squared minus t, and g of t is 3t plus 1. And they want you to find h minus g of t. Okay? So now I got to zoom back out. There, that's the whole problem. So if I'm going to do h minus g, I need to start with h, which is that one first.
Yeah.
So t to the third plus t squared minus t. And I'm going to put all of that in parentheses. Minus the g function, 3t plus 1. And now what? Good. So I'm going to distribute the negative, and I'll have t to the third plus t squared minus t. For the first group, I'm just rewriting it, but now I'm going to distribute this negative. Minus 3t minus 1.
Yeah.
Okay, now what? Good. So I can't combine the third power or the second power because they didn't have any, right? So it's just the t terms. So that's going to be t to the third plus t squared. Now what is negative t minus 3t?
negative 4.
Good job. Negative 4t minus 1. And then the label on that was h minus g of t. So there's our answer. Well, I think this is going pretty good. Let me see what I can do to challenge you a little bit. So let me find the next sheet of problems. Okay, now these problems have you putting in a number and evaluating for that number, okay? And these are a little bit complicated, but that's okay, we can do this. So let's start with an easy one, like, let's do this one, h of 4 plus g of 4, okay? So you can just do h of 4 and g of 4 and then add them together. So if you did 2 times 4 minus 2, what is that?
Yeah.
Good. And then if you do 2 times 4 minus 3, what is that?
5.
Good. So now h of 4 plus g of 4 is just 6 plus 5 equals 11.
Yeah.
That's actually kind of easy, isn't it?
Yeah.
All right, let's do f times g of negative 4 over here. So we're going to do 3 times negative 4 plus 2. So what's 3 times negative 4?
Negative 12.
Plus 2.
Negative 3.
Nice job. What is 3 times negative 4 minus 5? So now we have to do 3 times negative 4 is negative 12. And negative 12 minus 5.
Negative 23.
Nice work. Now we're going to do f times g of negative 4. So we have to take those two numbers, negative 10 and negative 17, times each other. So negative times negative is going to make your answer positive, right?
Negative 11.
Good. Positive 170 is the right answer. And then I'll just label the front end. So f times g of negative 4 is 170. All right, you're doing so good with this. So now I think you're ready for another challenge. What if they put in an expression? Goodness. So instead of putting just a number like this one, what if they give you an expression? So let me show you what I mean. What if they give you something like this? They want you to put a 4a everywhere that there was an A. So G of A is this, right?
Yeah.
G of 4a would be putting in a 4a where the A is. So that would be 2 times 4a minus 2. So what's 2 times 4a? Good job. So this will be G of 4a is 8a minus 2. Now we're going to find out what f of 4a is. So f of 4a is going to do a 4a right here where this a squared is, right? So we're going to go negative 3 times 4a squared plus 4 times A. So now I have to put a 4A where that A was. Goodness. So if I square 4A, I've got 4A times 4A, and that is good. So that'll be 16A squared times negative 3. Okay, so that's negative 3 times 16A squared. And then 4 times 4A over here, that's 16A. Okay. So now we just have to do one more little thing here. What is 3 times 16? So that is 48, and it's negative. And this is our answer for F of 4A. So now we're almost done, but remember, we're trying to do G minus F of 4A. So this is the F of 4A. This is the G of 4A. So I have to do this one minus this one. So 8A minus 2 minus negative 48A squared plus 16A. So now I have to distribute my negative sign. 8A minus 2 minus negative is going to be plus for the 48A squared term. Oops, I missed my 8. There we go. And then negative 16A. Okay, so now I can combine these two like terms, right? But when I rewrite my answer, I need to start the leading term with the highest coefficient. So that's going to be this 48A squared first. Oops, I did it again. 48A squared. That's this term. Now I can combine negative 16 and positive 8. What is negative 16 plus 8? Good. And I need to put the A with that, right? And then I need minus 2. Whew, that was a long problem. And I forgot to put G minus F of 4A equals that. Goodness. Do you feel like you're understanding everything?
Yeah.
Yeah, it's a lot sometimes, but you can do it. All right. I'm thinking we're going to do one more problem and then we'll be done, okay? Because it's getting late. So let's do, oops. Well, let's do this one right here. So this says G minus F of negative 3. We've been doing a lot of subtraction problems, but that's okay. Those are important. So we're going to be subtracting the G function minus the F function when negative 3 is put into it, okay? So G of negative 3 is negative 3 minus 2. So what's negative 3 minus 2?
Negative 1.
Good. And then F of negative 3 is negative 3 to the third power. Ooh, that's going to be a challenge. Minus negative 3. So let's work out negative 3 to the third power, Connor. That's negative 3 times negative 3 times negative 3. So let's just do the first two of those. What's negative 3 times negative 3?
9.
Good. So I have to do 9 times negative 3. Good, negative 27. So negative 3 to the third power is negative 27. And then I have to go minus negative 3. So minus a negative is plus, right? So plus 3. What is negative 27 plus 3?
Well, negative 24.
Good job, negative 24. Okay, so that is just our answer for f of negative 3, right? All of this that we just did was to find out f of negative 3 is negative 24. So next we have to do g minus f of negative 3. So the g of negative 3 was negative 5. So now for the g minus f of negative 3, we have to go negative 5 minus negative 24. So isn't that negative 5 plus 24?
Yeah.
What is that?
Uh,
24 minus 5 is 19. And that's our answer. G minus f of negative 3 is 19.
yeah.
Okay, I think we're good. I'm going to hit stop. Okay, so these are the notes that go with this part of the target. So what it is it's called a composition of two functions. So composition just really means they're being put together, like combined together. So that's not really too different from yesterday, but yesterday they were combined by adding, subtracting, or multiplying. This is one function nested inside of the other. So it's called a composite function. So a composite function is a function of a function. It's a function inside of another one. So see how right here, can you hear me, Connor?
Yeah.
Okay, I'm just hearing a weird noise. Okay, so see how right here in parentheses, there's a g of x inside of the parentheses with the f. So basically the g of x has become the input for the f of x function. So you're nesting one function inside of the other one. So let's look at this. So it says f of g of x, okay? And this is another way they might write it. Sometimes they might put this open dot. So that stands for of. So f of g of x. But it's better to write it this way. F parentheses g of x, like that, okay? So the way we say it out loud is f of g of x.
Yeah.
So you're going to plug in the g of x for every x in the f of x. Okay. Yeah. So since the g of x is shown right here in parentheses, that means that g of x has become the input.
Yeah.
Instead of just an x, the whole entire g of x is going to be put there, okay? Then you'll combine like terms and simplify. It says order does matter. You must apply the inner function first. So whatever's in the parentheses, that's what goes first. So let's just go ahead and jump in and do some, because this is something you really have to learn by doing. This first one says f of g of x equals what? And they're giving you these two function equations, okay? So that's going to be f of all of the g of x, because g of x is all of that, right?
No, I couldn't flip one.
Good. All right. So now what we do is instead of just having an x here, we have all of this. So that means we're going to take the f function. Let me color code this for you. We're going to do this with the input, right? Because f is all of that, right?
Oh, my one.
Right. So we have to do the 4x minus 1, but we have to treat all of this like it's the x, right? Because when this means take the x and go 4 times the x minus 1. So if this is my whole input, then I have to go 4 times all of this minus 1. So I'm going to go 4 times all of this minus 1. Yep. So now I have to distribute. And that gives me 8x squared plus 12 minus 1. And that's 8x squared plus 11. Okay? So that is my f of g of x function, 8x squared plus 11. Now down here it says, what is f of g of 1? So that means now I'm going to put in a 1 for x. I'm going to go 8 times 1 squared plus 11. Well, that's just 1 squared times 8. So 1 squared is 1, and 1 times 8 is 8. So this is just 8. Because remember, order of operations is that you do the exponent before you multiply, right? Because PEMDAS, right? You do, if you have parentheses, you do those, then you do exponents, then you multiply. So I have to do the exponent first, and that's 1 squared is 1. Then I go times 8. So this is just 8. And 8 plus 11 is?
9.
And now I'm just, what? It's blurry?
Yeah.
Uh-oh. Is it stopping with the blurriness?
Yeah.
Is it better now?
Yeah.
Okay. So f of g of 1 is 19. All right, let's do another one. Here, I'm going to move my speaker real quick. Okay. I'm going to move the paper now, and I'm just going to give it a moment to settle down. So is it still blurry?
No.
Okay. So f of g of x for this one would be f of x squared, because g of x is just x squared. So that's going there. Now that means that my input for the x function, instead of just putting in for x, I have to put in x squared everywhere that you see x. So that's going to be x squared minus 2. Okay.
Yeah. Oh.
And then that's it. There's nothing to combine. So that's my function. So f of g of x equals x squared minus 2. So that one was really easy.
Yeah.
But now we have to put in the -5, right?
Yeah.
Oh, I wrote the wrong thing there. I'm sorry. So I need to put x squared. So that's -5 squared minus 2. So what is -5 squared? Good. So that'll be 25 minus 2. And that's 23. So f of g of -5 is 23. All right, let's do another one. Now this time, instead of it saying f of g, it says g of f. Now it's got that little goofy open circle thing, which means the same thing as we've been doing, g of f. So it means g parentheses f of x is what that means, okay? It's just another way of writing g of f of x. So that'll be g of -3x plus 2. So if -3x plus 2 is my input in my g function, and my g function tells me my input has to go in the numerator with a 5 in the denominator, then I'm going to write all of this in the numerator and 5 in the denominator. So that's g of -3x. Oh, I should have written it a different way. I'm sorry. I need the original label. G of f of x equals that. Okay, that's a better answer. I'm just going to box it right here because my scribbles got in the way. Now down here it says find out what g of f of 2 is. So I can go and put in a 2 where this x is and write -3 times 2 plus 2 over 5. So that's -6 plus 2 over 5. And -6 plus 2 is -4. So that's -4 over 5. And there's my answer. G of f of 2 is -4/5. All right, here's example 4. G of f of x. So G of f of x equals G of square root of x. And the g function says whatever is here, you're going to go plus 2 and square that. So we have a square root of x to replace the x. So we have to write this, right?
Yeah.
Okay. So if I'm squaring this, I have to multiply this times itself. So I have to write square root of x plus 2 times square root of x plus 2.
Yeah.
Now I have to do this times this times that. So what is the square root of x times the square root of x? Do you know?
No.
Well, it's the square root of x squared. And we'll talk about that in a second, okay? We'll talk about how to simplify it in just a minute. Then we have the square root of x times 2. So that's plus 2 square roots of x.
Yeah.
It's kind of just like when you have a variable that's an x, you just write that thing instead. You write that square root. All right, then we have plus 2 square root of x here.
Oh.
And then we have
Oh.
2. Yeah, good. Now these two things here in the middle are like terms. So the next thing is I'm going to start simplifying, okay? So if I put 2 square root of x plus another 2 square root of x, that's 4 square roots of x. And I'm going to bring the plus 4 down. But I need to figure out what this is. So if you square a square root, it's opposite operations. They're inverses. So they eliminate one another. So the square root of x times itself is just x.
Yeah.
So this is our formula. X plus 4 times the square root of x plus 4. So now they want us to work out g of f of 4. So we're going to put 4 for both of those x's. 4 plus 4 times the square root of 4 plus, look, everything's 4s. That looks funny.
Yeah.
So what is the square root of 4? What number times itself gives you 4? 2, good. So this equals 4 plus 4 times 2 plus 4. Isn't this right here? This is going to be 8, right?
Yeah.
The 4 times 2. So we have 4 plus 8 plus 4. So what do you think that is? Good. That's your answer. All right, we have a word problem to do, okay? So let's do this. It says, a store is offering a 15% discount on all items. Also, employees get a 20% employee discount. Write a composite function that models taking the 15% discount and then the 20% discount. Okay, so here's what we can do. F of x equals, if you take 15% off, it's like you have 100% of the price minus 15% of it is taken away, right? So what's 100 minus 15? Let's look at that real quick. 100 minus 15. Good job. So 85% is really what you want, okay? So you have to go f of x equals 80.85 times the x. Because if you take that percent and change it to a decimal, you have to hop it 2 spaces, right?
Yeah.
Yeah. So this is the function that takes off 15%. Now, g of x, we need that to be our 20% off.
Yeah.
So 100 minus 20 is just 80, right? So this one will be 80. Yeah, exactly. Now they want a composite function. So in part A here, it says, take the 15% discount first and then the 20. Okay. So do you remember earlier I said you have to do the one in the inner parentheses first? You know, like you always start here, don't you? So when we go to write that, we have to put the one that we want to go first. So for part A, it says 15% discount first. Okay. So down here, I'm going to write this for part A, to do the 15% discount first. This is my 15% one, right? This one right here. That's my 15% off. That one has to go on the inside to go first. So I would have to do g of f of x, because the f is the 15% off one, right?
Yeah.
Okay, so let's look at how that's going to look. G of f of x would have to be g of 0.85x. And then the g function does 0.80 times it, right? So that's going to go 0.80 times 0.85x. Okay?
Yeah.
Okay. So if I multiply 0.80 times 0.85, let me get a calculator and do that real quick.
I can do it.
Oh, you got it? Okay. So we want to do 0.80 times 0.85.
Whoa. Ow. Uh,
Connor, what's wrong?
I can't open the
Well, that's okay. I did it on my own over here. I'll just write it out for you real quick. I'll show you. It's 0.85 times 0.80. So 0.85 times 0.80. So I'll go 0 times everything is 0. And then I'll go 8 times 5 is 40. 8 times 8 is 64, and 4 is 68.
Hey,
And then I have 1, 2, 3, 4 decimal places. 1, 2, 3, 4 decimal places. So I get 0.68 for my answer, okay? 0.68. So this equals 0.68x, okay?
yeah.
Okay, part B. Part B. To model taking the 20% discount first and then the 15% discount. All right, so let's do that one. That would just be f of g of x instead. F of, and the g of x function is this one here, this 0.80. And then if I apply the f function to that, that's the 0.85 function. So I have to go 0.85 times 0.80x. So I still have to multiply 0.85 times 0.80, right? So I still get the same answer, 0.68x.
Yeah.
So now let's look at part C. If you work there, if you were an employee, which one would you take first and why? Well, it doesn't matter, does it? It works either way because you're multiplying in both of these functions. So what order you multiply them in doesn't matter. Think about this. Don't 4 times 3 and 3 times 4 give you the same answer?
Yeah.
So since these are the same two numbers being multiplied, it doesn't matter what order you do it in.
Yeah.
All right, so if it's a multiplication problem, order's not going to matter. But if it had been division, order would matter. What's another operation where order matters? Does it matter what order you add numbers in?
No.
No, it doesn't. Does it matter what order you subtract numbers in? Like if I go 3 minus 2, is that the same answer as 2 minus 3? Those are not the same, are they?
No.
When I subtract, order does matter. So if I'm dividing or subtracting, then this could matter. But since it's multiplication, it's not going to matter. Okay. A few of these do whole paper. So let's this one first. First one. G of f of n. Okay, so that's going to be g of n squared plus 3. Right? Because the f of n is right there, right? So that's all good. Okay, so then that means they want me to do 3 times all of this plus 1. Right? There's my input.
Yeah.
All of this replaced just the n, right? So they're saying 3 times the input plus 1. So there's 3 times the input plus 1. So now we distribute. Yep. So 3n squared plus, what's 3 times 3? And then plus 1, because I have to carry that down. So that's 3n squared plus 10. And that's my answer. G of f of n equals that. Not too bad. All right, let's do this one. H of g of x. H of x is x plus 1. G of x is 2x. So if I'm going to do h of g of x, I'm going to put this g of x function right there. Yep. What do I write?
One.
So this goes there. Right? Because the h function takes whatever x is and adds 1 to it. So since 2x is the input, right? The gx is 2x. Since 2x is the input, I'm adding 1 to 2x. So then I can't really change that. So that's really, I don't need to write anything else. That's the answer. Okay. I guess I could have written h of g of x on my answer. I should have done that. Okay, are you ready to do a weird one? These are weird. I'm going to write this a little bit bigger for you because I know it's not showing up super good on the camera. That is just weird. They've done G twice. So you can do that. All right. So that's going to be G of x. Okay. So basically they're not even using their f function. They're just using a G function. Okay. And not an f. So the G function does 2x plus 1, right? So this will be G of 2x plus 1. So the G function tells you to take your input and go 2 times it plus 1. So we have to go 2 times all of this plus 1. Good. And then plus 1 on the end. So that's going to be 4x plus 3. Boy, that is strange, isn't it?
Yeah.
Let's do another one of those. They're just so weird. So this one is another g of x. So their g of x function is negative x to the third plus 3x squared. And we're going to go g of x. So that means we have to go g of all of this that's equal to g of x.
Yeah.
So we have to do all of this to all of that. It's kind of weird to think about. All of this has to replace each one of these x's.
Yeah.
So I'm going to go negative sign first, and then put all of this, negative x to the third plus 3x squared. And then it has to be cubed. And then I have to put plus 3. I'm going to need more space. Times all of that, negative x to the third plus 3x squared. And it has to be squared. Okay?
Yeah.
So there's my negative x to the third is negative all of this to the third. And then my plus 3x squared is plus 3 times all of this squared.
Yeah.
Now, what do you think I have to do?
What?
I have to distribute now. But, oh, I can't distribute because of the exponent. Is that what you were telling me to do? I have to do the exponents first. Oh, my goodness. This is a tough question. I'm not going to lie. It's a lot of work. Here's what they're saying. They're saying this. That's just the first part. All of this. Because to cube something, doesn't it mean multiply it times itself 3 times?
Yeah.
And then we have to go plus 3 times that squared. Oh my goodness, that is a lot of work. Connor, all I can say is we are not going to do it.
Wow.
It would take us so long to work that problem. We will never have one that tough on the test.
I
But
want
you want to do it. Of course you want to do it. Oh my gosh. Yeah, we can try. We'll start it, but we might get to the point where we're exhausted. Let's try. We'll try. Here you go. You asked for it. Here goes nothing. So what you have to do is you have to take the first pair times each other and get that answer. And then after you get that answer, then you do it times this one. So let me just start with negative x to the third plus 3x squared times negative x to the third plus 3x squared. Okay? So we're just starting with this much of it. So we're just going to do this part first, okay? Okay. You're right. We're going to multiply. So we're going to do negative x to the third times negative x to the third. And we're going to get, oops, hold on. Let me tip my paper the right way. Okay. When we do negative x to the third times negative x to the third, that gives us positive x to the sixth. Then when we do negative x to the third times 3x squared, we get negative 3x to the fifth. Then when we do 3x squared times negative x to the third, good work. And then when we do 3x squared times 3x squared, what do we get? You are so awesome. All right, now here in the middle, we can combine like terms, right? So that's negative 6x to the 5th in the middle. And I'm going to carry down x to the 6th and carry down 9x to the 4th. Now, all we have done is a pair of these times each other. So that can replace this part here. And it happens again down here. Okay, so we've done part of the work. So I can put 3 times this answer here that we just got. I can put 3 times this, and it can replace that. But I also have to keep going and go times another negative x to the 3rd plus 3x squared. Okay, so first I'm going to just rewrite this answer with a 3 times in front of it over here for later. Okay, plus 3 times all of that, x to the 6 minus 6. We keep going with this one because this one still has to go times another one of those.
Yeah.
So now we have to do this times both of those and that, well, times all 3. So don't you like it better when you have this on the front when you're going to distribute? So I'm just going to take this and I'm going to rewrite it on the front. I'm just going to eliminate that back there. Okay. So we're going to distribute now. We're going to go the negative x to the 3rd times x to the 6th first. So that's negative x to the 9th. Then negative x to the 3rd times negative 6x. So what does that give me? Positive 6. It's negative times negative, so it's positive 6x to the 3 plus 8 power, right? So x to the 8. Yep. And then negative x to the 3rd times 9x to the 4th. So that's going to be negative 9x to what power? Good. Now, now we're going to go through it all again with the 3x squared. So now we have to do 3x squared times x to the 6th. So that's going to be 3x to the 8th. And now we have to do negative 18, right? And then x squared times x to the 5th is x to the 7th. And then this term. 3 times 9 is 27. Yep. X to what power? Good job. Now we have to combine like terms. We can go with these 2 together and these 2 together. Okay, so we'll have negative x to the 9th, and then 6 and 3 makes 9x to the 8th. So that takes care of this and this and this. Negative 27x to the 7th. That takes care of this and that. And then I'm going to carry down 27x to the 6th. Okay. And now we still have to go get all of this. So this is 3x to the 6th minus 18x to the 5th plus 27x to the 4th when I do this, this, and this. So now that combines with the other answer, and it means I have to put together the 3x to the 6th with the 27x to the 6th, don't I? Oh, goodness. All right, so I'm just recopying that other part. Okay, so now can you even see the whole problem at once? Oh my goodness.
Yeah.
Okay, so I have to put these two together now, and then I'll be done, okay? So negative x to the 9th plus 9x to the 8th minus 27x to the 7th. Then 27 and 30 is 30 plus 30x to the 6th minus 18x to the 5th plus 27x to the 4th. Well, are you happy that we did the whole problem? I told you it was a long problem. Okay. I'm proud of you that you wanted to do it, but that was a long problem.
I owe you. Oh, no. Oh, my God.
Let's do, I think I would like to do number 7 here. H of G of N. So that's going to be H of the whole G function, N squared. Take your input of N and go 3 times N plus 1. So we're going to take all of this times 3 and go plus 1.
Yeah.
So that's 3n squared minus 15 plus 6n. Oops, that's an n. Plus 1. And then I can combine like terms with my minus 15 and my plus 1. So that equals 3n squared minus 14 plus 6n. Whew. And that is your answer. Goodness.
And no, what the one.
It's better than the last one, isn't it? Okay. Let me see. So I'm going to go to the back of the paper, the next sheet really, and I want to look at some other things because I want to remember what we learned yesterday, okay? So I want you to notice how today we have these little open dots, but yesterday we had just a dot there, right? This is a multiplication dot, but that dot means to do H of G of X, right? So that's not really times. That's like put the function inside of the function, right?
Yeah.
But over here, when I have G dot H, I want to do G times. So I want to go the G function times the H function.
Yeah.
Okay, so let's practice some of that.
Negative.
That will just mean doing distributive property. Negative what?
Negative.
4 n to the 3rd power, right?
Yeah.
And then minus this times this is 4n squared.
Yeah.
Okay? Okay.
Yeah.
And I'm going to label my answer G of H of N. I like writing it with the parentheses instead of the times dot because I think the times dot is confusing.
I don't remember.
Good. Okay, next. So let's do one more multiplication one, and then I think we're done for the night because it's time. So we'll do this one right here. This one says do G times H of N. So that's the G of N is 3N minus 1. And the H of N is N squared minus 5N. So now what do you do? Good. So when we multiply these, we'll have 3N to what power? To the cubed? Is that what you said? Cubed?
Yeah.
Yeah. Okay. Then we'll have minus 15 n to the second. Then we'll have this. So that's minus. And then what's -1 times -5?
5.
Just positive 5, right? So that last term will be a positive 5n. Now I can combine like terms here in the middle. So I have 3n to the third minus 16n to the second plus 5n. And that's my answer. G times H of n equals that. Okay?
Yeah.
Now, something we did not have today in any of our practice, we didn't have problems where you have to plug a number in, okay? So I'm going to do some of those with you really quick. So what if we had, and we're just going to do 2 with a number in here. What if we had to do G of H of 3? Okay, so what if it said find G of H of 3? Then that would mean G of, and I need to know what to put for H of 3, okay? So I need to work out over here, what's H of 3? So H of 3 would be 3 squared plus 5 times 3. So what's 3 squared? 9 plus 5 times 3 is 15, right? So that's 9 and 15, which is 24. So H of 3 is 24. So when I want G of H of 3, that's going to be G of 24. Well, I can find out G of 24 just using this equation up here. That's going to be 3 times 24 plus 2. Yeah. So 3 times 24, that's 72. So 72 plus 2 is 74. That is easy. When they give you the number to put in, so easy. When they don't give you the number, you have to do all this kind of work because they gave you an X and not a number. But if they give you a number, oh my goodness, so easy. You can just plug it in and work it out. Let's do another one like that. So let's do, I'm going to rewrite these functions just so you can read them better. This says G of X equals 3X plus 1 and H of X equals X squared plus 2. And they want you to work out G of H, and I'm going to say G of H of -4. Okay? So that means I need to find out the H of -4 to put inside here. So H of -4 equals, and I could put it in this function, right? So I have to do -4 squared plus 2. So what's -4 squared? 16. Okay, so 16 plus 2 is 18. Right? That's my h of -4 answer, 18. That number is going to go right here now to do g of h of -4. So I have to do g of the h of -4, 18 number, which is going to be that. So g of 18. Now I go to my g function, and it says to do 3 times x plus 1. Nice. Now 3 times 18 is 54, and 54 plus 1 is, and that's our answer. So g of h of -4 equals 55. Okay? All right, so it is right about time. So I'm going to hit stop. We still have to do some practice together with word problems tomorrow, okay? But okay, so we're going to be doing, first we're going to do some word problems about functions. And remember, this week we've done function operations, and we've done composition of functions like f of g of x, right? So we have to review both of those things with our word problems, and then we have to learn one more new topic, and it's called inverse functions. And then we'll be done with all the new topics, okay? So let's go ahead and get this started. I'll put my camera. These word problems are printed in little rectangles like that, so that it makes it easy to cut them up and do different things with them. But anyway, we'll just work with it. So hopefully you can read that well. It says, a store offers a 20% off discount to all customers on Mondays. And you also have a $3 off any purchase coupon. D of x equals 0.80x models the discount, and C of x equals x minus 3 models the $3 off coupon. Which is the better deal? D of C of x or C of D of x? Say that again. Oh, you think it's going to be C of D of x? Okay. So let me grab, I need blank paper. And my office is a mess. This room is so sloppy. I'm so sorry. Okay. We've got down some blank paper. Here we go. So we are going to do this problem both ways, and we're going to find the answer to that question. So D of C of x would be, oops, this paper's all twisted. There we go. D of C of x would be D of x minus 3, right? Because there's the C of x. So this goes inside of the D of x function. Okay. So then that means I have to go look at the D function, and I have to figure out what does D do to things, and then apply it to this new input. So the D function says you take your input and you go 0.80 times your input. So we have to take this input and do 0.80 times this input. Yeah. So then we have 0.80x minus. Now 3 times 8 is 24. So 3 times 0.8 is 2.4. Okay? No, actually, we're going to stop there. We're not solving for x. We're just stopping there. We're trying to find out what's going to be the better deal. So hold on. It's going to be, this is d of c of x. Okay. Now we have to do c of d of x. Okay. So I'm going to draw a line to separate my workspace. And now we'll do c of d of x. So that's going to be c of d of x is this.
Yeah.
Yep. Now the c function says take your input and go input minus 3. So I have to go this input minus 3. So which one of these is the better deal? To get the better deal, don't you want to pay less money?
Yeah.
Yeah. So both of them is doing 80% of X, and then one of them takes off $2.40, and the other one takes off $3.
That's right. You know,
Exactly. This is the better deal. And you know what? I'm pretty sure that that was the one that you guessed, isn't it? Didn't you tell me C of D of X? I
yeah.
think that's the one. So you guessed right. Good job. Do you have somebody there helping you figure that out?
No.
You just figured it all out, didn't you? You know what that means? That means you should be like a professional shopper because you know how to get the best deal. I bet you don't love shopping though. Most boys don't like shopping.
I do.
You do? You do like going to the store or you don't?
I will walk
All right, let's
Walmart was my
what about Walmart?
it was my fault. Now I love to go shopping.
Oh, okay. That's one of the places I go shopping at all the time. That's where we get all of our groceries. Okay, so let's look, well, maybe not all of them, but a lot of them. Let's look at this one. The price of a printed t-shirt P is modeled by the function P of X equals 10 plus 3.35X. A store is offering a discount D modeled by D of X equals 1 minus 0.15 times X. Write a function that determines the discounted price of a t-shirt. So the discounted price of a shirt, well, the discount is the D function. So basically they're saying discount of a shirt. A shirt is P, right? So discount of the printed shirt. So you have to do D of P of X. Okay?
Yeah.
All right, I'm going to go back to my paper where I have some work room, some blanks.
The one is what we buy at.
Right, that's what D does, but we can't do D first. We have to go get the P first and put it inside of D. So the P is 10 plus 335X.
That what I
Oh, okay, I'm sorry. So that's going inside of D. Okay. Now let's look at what D does. D takes your input and goes 1 minus 0.15 times your input. So we're going to go 1 minus 0.15 times all of that.
yeah.
Okay. Now, 1 minus 0.15 is a number that we can work out. So I want to do that first. I can kind of simplify that. 1 minus 0.15 is 0.85.
Oh, yeah.
And then now I can do what? Good, I'm going to distribute. So 0.85 times 10 would be 8.5. Because if you multiply times 10, you just hop your decimal over. I just realized I don't have the light. Can you see better now? I didn't realize, but the light was turned off. So I turned the light on. Okay, I'm sorry about that. So then 0.85 times 3.35x. Ruh-roh. I'm going to have to do that. All right. 3.35 times 8.5. All right, I got 28.475 when I work that out. So that's going to go plus 28.475x. Okay?
Yeah.
And that is the function. Yep, that's the answer. They just wanted you to write the function. So this function tells you the discounted cost of a shirt. Seems weird. Something doesn't seem right. I must have added wrong.
1.
I see what it is. It's because when I multiplied all of this, I was supposed to multiply times 0.85, and I did times 8.5. So I needed to move my decimal one more space. So it's 2 point, so this should be here. I just knew it was way too much money because it's supposed to be the discounted price of a shirt. So how could a shirt cost, $8.50 plus $28.04? It didn't make any sense. But now it's like 2.8.
Yeah.
So now it makes sense. I knew there was a mistake in it somewhere. Okay, let's look at number 3. The heart rate of a white rhino R in beats per minute and lifespan S in minutes are related to body mass M using the functions below. So this is the heart rate. Remember, it says R is the heart rate of a white rhino. So this is the heart rate, R. And then the lifespan is this one, the S. Lifespan. Okay. It says find R of S of M. So basically what it's saying is you can find the heart rate depending on the lifespan. Interesting. So I think what that means is, what do you think it means? If they're saying the heart rate depends on the lifespan, what do you think that means?
We're gonna multiply. I don't know.
That's okay. You're not exactly going to multiply. You're going to put this lifespan function into the heart rate function. So basically, the heart rate is going to change depending on the lifespan, is what that's trying to say.
Yeah.
Trying to say like something about maybe the older, like the longer a lifespan is, that somehow changes its heart rate, something like that. I'm not sure. So let's go ahead and work the problem and see what happens. It says R of S of M. So we're going to write that means R of, and I need to put the S of M inside of there. So I'm going to put 6 times 10 to the 6th M to the 0.2, okay? Now, this is some weird looking stuff, isn't it? You have a decimal on your exponent, so we're probably going to need a calculator, but that's okay. Now the R function does 241 times M to the negative 0.25 power. Goodness. So I have to put all of this right here where M is.
Yeah.
So I have to write 241, and then I have to put 6 times 10 to the 6th M to the 0.2. And I have to put this exponent on the end. Goodness, that's a lot. Okay, so first things first, this is a number. 6 times 10 to the 6, it's scientific notation for a really big number, okay? So the first thing I have to do is I have to think about my order of operations here.
Go help from there.
Do the exponent first? Yeah. So I don't know if you remember this. Let me do something that doesn't look so complicated for a moment. I want to know if you remember doing this in Algebra 1. If you had something like this, and then you put an exponent outside of the parentheses like this, do you remember me showing you that you have to distribute that exponent?
Yeah.
And you end up with x to the 4th power, y to the 6th, because you have to multiply the exponents when you have an exponent outside of parentheses.
Yeah.
So that's what we have to do here. So we're going to multiply this exponent times this one and times that one.
But this guy won't be on my that.
But what?
Will this guy be on my that? Will you put this guy on my quiz?
Oh, no. That won't go on your quiz. No. All right. So.
Oh.
Oh, and I also have to distribute it to the 6. My goodness. Okay. So that's 241 times. Oh, this is just a mess. 10 to the 6 times negative 0.25 is going to be 10 to the negative 1.5. And then the M is to the positive 0.5. Whew. This doesn't look like it, Connor, but these are all numbers. And there's only the M left. So I'm going to put a calculator on the screen and show you that I can multiply all of that on the calculator, okay? I'm going to put Desmos on the screen. So real quick, I'm going to open up Desmos first.
Can you put them on my Google Cloud? No way. I have it. I need it.
Sure. Here, I'm going to get a link for it, and I'll put it in there. Okay. So this will be for Connor, and it'll be I'm just going to type calculator on it, and then I'm going to add the link, paste, add link. Okay, it's there now. So anyway, I'm going to come back to you now. And I'm going to present my screen so that you can see the calculator. Okay, so you should be seeing my calculator. I'm going to type the whole problem in there, okay? So it said on our screen, it said 241. And then it had a parentheses, 6, and that was raised to the negative 0.25 power. And then that was times 10 raised to the negative 1.5 power. And then that was it. Yeah, okay, so now I have to close my parentheses and hit enter. So this is everything that was on our paper, okay? And here's the answer, 4.869442366, okay? So I'm going to write that down on my answer blank on the paper, but I'm going to round it to the nearest hundredths. So I'm going to just keep 2 spaces after the decimal. I'm going to go.
You get them all of them. That way I can log you like.
Yeah. So I'm going to press stop on that. Okay. So the number was 4.869. So I'm going to write that that's about 4.87 m to the 0.5 power. And that's our answer. Okay?
Yeah.
Because I typed all of these numbers, you know, the 241 and the 6 to the negative 0.25 and the 10 to the negative 1.5. I typed all of that into Desmos and it told me that the number equals this. And then after that, I just put m to the 0.5 on the end. Okay? So that is it. So like you said, we will not have one that's that difficult on the actual test because it's too many. Go box it in. Okay. Oh, I forgot to put R of S of n. Okay. Next one. From 2015 to 2019, the number of cruise ship departures in thousands from around the world W and from Florida F are modeled by the functions below. W of t equals this, F of t equals that. Find W minus F of t. Okay? So we're going to go with the W first, right? Because it's W minus F. So order matters. We're going to put W first. So I'll write all of this first, and then I have to subtract the F from it. Okay? So I'm going to scoot my keyboard out of the way real quick. All right. So I have to write negative 5.833t to the third.
Plus.
I'm just recopying the function, okay? So that's the W function. And I have to subtract the F function from that, right? So now underneath it, I'm going to write the F function with a subtraction, okay? So that means I'm going to have to minus each of the things one at a time. So minus 12.5t to the third. And then I have to go minus negative 60.29 t squared. So if I minus a negative, doesn't that mean I have to add? So I'll go plus 60.29 t squared. And then the next thing is 136.6, right? So I have to go minus that. And then I have to minus the 4,881. Okay, so let's look at the problem now. I'll take the other paper out of the way. So we have to minus the things that are like terms, right? We're going to subtract the like terms. So those two, okay? Since they're both negative, I'm really just going to add it and keep that negative. So that will be net. Oh my goodness, this is a lot. Okay. 3, 3, 8. Oops, the decimal goes there. Okay, so that's 18.333 t cubed. All right, so next thing we have to do is these two.
Yeah.
So those are both positive, so we're going to add those. So we have a 3 and 9 is 12, carry 1. 1 and 4 is 5, and 2 is 7. 7 and 0 is 7. 1 and 6 is 7. So this is plus 77.72 t squared. So now that takes care of that one. Now we have to add these. We're just adding our like terms, right? It's a lot of decimals. This one is positive, but that one is negative, okay? So let me rewrite this to the side because they're not lining up. This is 509.1 minus 136.6. So I got 372.5 t's, because those are just t. And then the last thing is 11,496 minus 4881. I'm going to go over here, 11,496 minus 4,881. That is 6,615. Whew, that is a big, huge answer. My goodness. We did it. Where do you want a comma? Right here?
Yeah.
Okay. I'm going to go close my door really quick because it's loud in my house. Hold on a second. Somebody's watching TV and it's really loud. Okay.
Yeah.
Okay, so now let's go back to what the problem was talking about. This was the number of cruise ship departures in the whole world, and this is the number of cruise ship departures in Florida. So we did the number in the world minus the number in Florida. So they say explain that in context. Basically, that's how many cruise ships have left from everywhere in the world except for Florida, because we took out the Florida ones. We subtracted out the Florida ones. Okay. All right, let's go to my next sheet of problems, and I'll just try and pick.
And when are we gonna do the no?
Inverses, we're going to do those in just 1 minute. We're going to do one more problem, okay? We're going to do this one with the table.
Hey, can you make a new recording when you stop, let me know.
Yes, I can do that. Okay. This says the table below shows the outputs of the two functions f and g. All values of x shown in the table. Wait, I'm sorry. I skipped a line. Use the table to evaluate f plus g of x for all values of x shown in the table. So here's f of x and here's g of x. So here are the values of x. So they want us to do this plus this. So let me give you a new piece of paper to help you see. So f plus g of 0 would just add these two together. So that would be -2 minus 1. So what's -2 minus 1?
-4.
Good. And then f plus g of 1 would be -4 minus 3.
-9.
Good job. F plus g of 2.
-2.
Good. F plus g of 3. -21. And then f plus g of 4. Ooh, that's a tough one. Let's do this one over here. So that's 57 minus 26, 31. So this is negative 31. Okay? Okay. So basically all we had to do was add together the f of x and the g of x for every single x. Okay. So we're done with that. Let me press stop because you said you want a new recording for the inverses. This is notes on inverses. We're going to find the inverse of a relation or a function. An inverse is just the reverse or opposite of something. Okay, so it basically takes something and does it backwards. So you can just switch your x and y variables and re-isolate the y in your new function. And then over here, this is telling us how to test for whether something is a function using the vertical line test. Because you can look at a function and see if this is not a function because this vertical line is touching it twice, but this one is because this vertical line is touching it once, right?
Yeah.
Okay, so the reason this is here is because a lot of times, or sometimes when you create the inverse, sometimes the inverse is no longer a function. So they will ask us sometimes, is the inverse a function or not? This is a little bit blurry, so I'm just going to write it a little bit bigger. It says y equals 3x minus 1, and it's asking you to find the inverse, okay? So we are going to do a switch of the variables. We're going to write x equals 3y minus 1.
Yeah.
And then we're going to resolve it for y.
Yeah.
So if we want to isolate this y right here, what should we do? Good. So that gives us x plus 1 equals 3y. Then what?
No more.
Divide by, and now we have y equals x plus 1 over 3. Right? And what?
It will be.
Yes, it is really easy. And you can rewrite this. So there's this interesting thing that some people, they call it the heart method. It's a way of helping you remember how to split that answer up. So I'm going to rewrite your answer. You probably can't see that very well. Let me get this darker. You do this and you do this. So you put the x over 3 and then you put the 1 over 3. So that's also equal to x over 3 plus 1/3.
Yeah.
Okay? All right. So that's y equals that. All right. So let's do another one. What? What did you say?
I can keep the other one. Yeah, I want.
Yes, you can. So the only reason that you would pick this one is if they ask you to graph it. Because this one is easier to put on the graph, because what's your slope? Your slope is like 1/3, and this is your y-intercept. It's kind of hard to make a y-intercept of 1/3 though. It's very hard. So it sort of makes it easier to graph and sort of not. But anyway, this would be the graph of it. I put a dot at 1/3 and then I went up a square and over 3 squares. And I graphed it. All right, so we are going to try and do inverses on some more. You ready? So the steps for making an inverse are you can switch your x and y variables and then you resolve for y. So we're going to switch this x and y. We're going to write x equals y squared plus 4 and resolve this for y. So what should I do? Good, minus 4. And then that gives me x minus 4 equals y squared. Now, how do I solve for y if I have y squared? What do I have to do to unsquare something? It's square root. Excuse me, I'm tired. Square roots. So then the square root of y squared is y, and this is square root of x minus 4. So I have y equals the square root of x minus 4 for my answer. Okay?
Yeah.
Okay. All right, here's the last question. State whether the given functions are inverses or not. Is this the inverse of that? Well, let's just do the inverse of this one and find out. If I switch the x and the y, I would have x equals y, wouldn't I? And then isn't y already isolated? So this is kind of the inverse of itself. Kind of, huh?
Yeah.
Now, if I did the inverse of that, it won't be the same as this. So no, these are not inverses. This is the inverse of itself. This is its own inverse. But I do want to find out what is the inverse of this one, just out of curiosity. I'm wondering what it might look like, okay? So I'm going to go ahead and do it. So to do the inverse of this one, I would write y minus 1/2 x equals 0. And I have to solve that for y, right? So what would I do to get y by itself? I have to add the 1/2 x to both sides. And that would give me y equals 1/2 x. So So the inverse of x minus 1/2 y is y equals 1/2 x.
Yeah.
Yeah. Let's do one more just to see what happens. I wonder if we had, what if we had y equals 2x? I wonder what the inverse of that is. Let's think about this for a second, okay? We're going to use, instead of using the same method, we're going to think about what is backwards from that, okay? So this function, y equals 2x, doesn't it just double the x? You know, 2 times x, it just takes 2 times whatever number you give it, right?
Yeah.
So what would be the thing that would undo multiplying times 2? What's the opposite? Dividing by 2, exactly. Or like half of something is really the same idea as that. So we're expecting to see a 1/2 or a divided by 2 when we do the inverse. So let's go ahead and do it. It would be switching the x and y's, I would have x equals 2y. And then to resolve that for y, I would divide both sides by 2. And then I would end up with y over 2, which is the same thing as 1/2 x or x divided by 2, right? So this and this are inverses, and that makes sense because this function is dividing by 2 and this function is multiplying by 2.
Yeah. Yeah.
And those are inverse operations, right? Multiplying and dividing are inverses.
Yeah.
Yeah. Let's go back to the ones we did earlier. Let's look at this one. This was squaring and adding 4. So the inverse function that we got as our final answer is square rooting and subtracting 4, because those are opposites of squaring and adding.
Yeah.
Yeah. And then let's look at the first one we ever did. This one's taking and going times 3 minus 1, but the final answer is divide by 3 and add 1.
Yeah.
Yeah. So that's what inverses do. They do the opposite operations.
Yeah.
All right, well, that's all I have to show you about inverses. I'm wondering, can you remember how to do them? Let's look back at the notes. This is all you have to do to get an inverse. You switch the x and the y, and then you isolate the y. That's all you have to do to get an inverse.
I can make up or I don't know you how to do it.
Can I make what for you to tell me how to do it?
Make up a problem.
Oh, make up a problem? Sure. So that you can have a practice? I can do that. Let's do this one. Y equals x minus 3 divided by 2. Okay, tell me what to do.
You gotta flip.
Switch the x and y. Okay.
No, I flip the body from my
Good. So I'm going to multiply times what then?
no.
Good. So that gives me 2x equals y minus 3. Now what?
Divide by
What are we trying to isolate?
the what?
Yeah.
Ah.
Good. Good. Good recovery. So this would be 2x plus 3 equals y. So the final answer is y equals 2x plus 3. So this is the inverse of that. Okay?
Yes.
And that makes sense because this is dividing by 2 and this is multiplying 2. This is subtracting 3 and this is adding 3.
Yeah.
Okay. All right. You want to do one more?
Yeah.
Okay, this will be the last one. I'll make it I'll just make it one more level of difficulty. So y equals 2x plus 1 over 5. There you go. So what do I do first?
Gotta
Okay. Now what?
multiply by
Times what?
5.
Okay. So now I have 5x equals 2y plus 1 because those cancel each other out.
Divide by 1.
Which variable are you isolating now?
The y.
Okay, so what should you do first then?
Minus 1.
Good.
Or
Now I can divide, right?
divide by 3.
Good. And then I can do the heart thing if I want. So the heart thing is this and this. So I go y equals 5x over 2 minus 1/2.
Yeah.
Okay? All right. You feel like you got this?
Yeah.
Good. Okay. Now I'll go ahead and press stop.